welcome to my channel. So, in this is the introductory video of the series where we will build this GUI app that you can see on your screen. It's okay if this doesn't make much sense at this time, all these buttons and all. But this is a quantum visualizer. I call it quantum glasses, as you can see. And this entire series is a part of something big. So actually, after we complete this tool, uh, making this tool display a playlist, uh, I will start the tutorials on single qubit gates and quantum computing, the quantum algorithms, and we will progress bit by bit. But to get the basics clear, I just don't want you to just take down the math. So while you are taking down that math, trying to understand the mathematics, you also will be able to visualize everything, and this tool will help you to visualize it. So let's see how is that possible. So for example, all these buttons here are actually denote quantum gates, single qubit gates, and all of these gates can be you know imagined as a sort of matrix. So we have a concept where multiplying h two times, like using this h two times, will result into an identity. So it just gives you back, it takes you back from where you started. So let's just first apply it once and see what happens. So I applied it once and I will now try to visualize this. So as you can see, it started from here top and now it's moving. So this is a state, is a what's all this we will just go through in the series. So as you can see, it stopped here. So applying this gate rotated this vector from here to here. What's that? We will see it mathematically. But now, as I told you, applying twice will bring us back to the same state. So you already know what applying once does, right? If we get it perpendicular to the actual state. So let's see, I now applied twice. So we should get back to where we started, again on that x-axis, right? So let's visualize it now. See, I've applied it for the first time, and it's moving. We will get back here. We know that we have already seen that. So yeah, it's moving. It's moving, and we should get it here, where you can see x written. This has a x-axis, and yes. So you can see that applying these two h actually did not have any effect. When we applied h for one time, we got here, and we applied it again twice, we just got here. So it just means that applying these two did not result into anything, just a rotation around it, and we are back where we started. So this is one of the examples that how you can use this tool, and there is a reason behind doing this. So uh, for, for anyone who is from computer science background, it will help you to understand the basics of quantum computing. So all these gates you can see x, y, z, s, t, h, all these gates have a meaning. So you will understand these basics uh, after going through series, and we will talk about it much more mathematically after this entire playlist. And talking about the people from physics background, like for example BSc in physics, so you may be wondering how to start with programming. That's one of the problems that people face. So then this playlist will have both. So it will you can see this program, right? Just minimize, let me minimize this. You can see this project took me around 250 lines, say for it, approximately. So this will help you getting started, and you won't just have to follow step by step a tutorial of Python. Python is the best language to start, especially for machine learning, also for quantum computing also. So you will learn Python while actually working on a project. So you will understand how each and every concept actually comes into play while you are working on project. So the advantage of doing this tool is that, well, while you are actually learning math and stuff, it will help you as a tool that will help you to visualize things. And when you visualize things, you remember and understand it, in a very much better way. And the other point is, it will bring us all on the same page, right? So even if you are from computer science background or a physics background, if you are from computer science background, it will help you to understand the physics. And if you are from physics background, it will help you to understand the basic programming of Python, and how things work. And plus, if you are someone even from computer science background who don't know much about Tkinter or GUI apps, it will help you to learn that too. Plus, before even you just start the actual math and quantum computing, you will already have a project that you can showcase, and it will also give you a sense of some accomplishment that yes, I have done this, and it will be a great way, as we say, learning by doing. So it will be a great example of that. So the and the next video we will uh, start by installation, the packages that we will require to make this project, and I hope to see you there. Thank you. Hello, all the people from YouTube. So as we saw the introduction to this project that we are about to build, the quantum glasses visualizer. This is a quantum computing based app, GUI app, for visualization, and we have discussed in the previous video what this project is all about. In this video, we will go through the installation purposes. So the first thing that you need to do is install Anaconda. And there are many videos how to do it on YouTube. You can just search how to install Anaconda, and that's it. So the two things that you need to remember is first creating a Conda virtual environment. So what is this virtual environment? See, this is maybe this might be your first project, but definitely you will be working with many projects on your system, and some packages or libraries that we use demand different versions. So some version may demand 3.8, some might demand 3.9 version of Python, and so on. And not just with Python, the libraries themselves have various versions, and working with libraries all together may make just mess. It might just mess up if you install it all on the PC and all. So what is this virtual environment? Just think of it like a private Facebook group. Only the members of the Facebook group can reply to posts or create posts in the Facebook group. No, none of the member who is not a part of the group can post. In a similar way, when you create this Conda environment, only the packages or libraries that you install will work. None of the libraries that are not installed will, it won't cause problems into a project, and you can peacefully work on your project. And similarly, you can create a new environment for another project, and the libraries that you install here won't interfere with that project. So that's the reason we work in virtual environment. So on the screen, what you see here, so this screen what you can see here is Visual Studio's code, VS Code we popularly say, and it's a great editor. So we write code here, we execute it here, and there are various IDEs that you can use when you will install Anaconda, you will also get Spider that you can use too if you're comfortable with it. There is another popular, editor. We have PyCharm, which is very popular. You can use that too if you like it. Again, both of these are very popular. You can just Google or see about it on YouTube and just think about which one you want to go with. But I would recommend using Visual Studio Code because VS Code is great. It supports multiple languages. So maybe after Python, you think of going to some other language, and Visual Studio Code again, VS Code will help you with that. Again, this how to install this. There are many videos about it. You can just go through it, and I will uh, leave a link to in the description of one video that I think will cover everything on how to install Anaconda, how to install Visual Studio Code. So I think watching that will be sufficient for you. Now, after you have downloaded Anaconda Python, and know that you need to download Python 3.8. 3.9 might be a little problematic with Qiskit. So what is this Qiskit? Let's see. So the second point that I mentioned earlier is installing of packages. So here we have these two packages, Qiskit and Tkinter. Again, Tkinter is very simple to install. It won't be much of headache. But Qiskit is the big boy of our project. So people from physics, we may say that Hamiltonian is the big boy H, but here for our project, trust me, Qiskit is the something that is and is the main thing. Qiskit will give us all the quantum functions and quantum computing power that we need for our project. So, how to install it? As you can see, they themselves recommend to install Anaconda. So, it works on all these uh, operating systems. So, after you have completed the installation of Python 3.8, Anaconda, your favorite IDE, whatever you are using, just and make a folder where you want to work on this project, and then open your Anaconda prompt. After you have opened the Anaconda prompt, write conda deactivate. That will deactivate your base virtual environment that comes by default with Anaconda. Navigate to the your directory wherever you have created that folder where you want to create the project. Use the command cd for uh, I'm talking about Windows, and maybe a different, maybe a command, maybe different with respect to your operating system. So you navigate to the directory where you have created the folder and write this command conda create -n. This environment is your environment name. Maybe you can give it any name. I gave it quanta. So yeah, just write this command, and the only change you need to make is Python equal to 3.8. That's the only change. Just copy this command. Just make that one change. Python equal to 3.8, and just press enter. Then on the next line, you can write conda activate whatever your environment name is. After this is done, you need to do this. Pip install Qiskit visualization, because essentially we are using a visualization tool. So it's better to go with this. I have not tried this. I think this should work fine too. This command should work fine too. But to be on the safer side, we will go with this. So after you have done this, and again note this for the people in Mac OS. You have a change. You have to do this command. Just insert it in this single inverted commas. So this should install your Qiskit. And after you have done it, you have to just install tkinter, and for that you can just write pip install tk. So you can see here we have pip install Qiskit. Just replace this Qiskit with tk and you are just done. So that should be fine, and after you have done that, I think you will be just ready to start the project. So let's see. So let me just make another file and show you. Say I'll just name it tutorial.py. So the extension this .py signifies that this is a Python file. So if you have completed the installation successfully, see this is showing me Qiskit. It means my Qiskit is very well installed. And after I run this tkinter, see again it's showing me tkinter. It uh, it means that I have successfully installed both of these packages and I'm all set to go ahead. So I hope you found this tutorial useful and I hope you install it successfully. I'll watch you in the next video. Hey there, welcome to the third video in the series. And this video is just for a little extra help to the beginners. So if you are struggling yet to make the environment and maybe you're facing some issues, so this is the video that might just help you. If you have successfully installed tkinter as well as Qiskit, just feel free to skip this video. So now let's first in the search box type for Anaconda. So it will by default we have this base environment that will be activated, so we shall deactivate. You can see the base written beside the directory has been wiped off. So now just go to the directory where you have kept your project, so where you want to build the project. For me it is in the D drive, so I have navigated to the D drive, and in D drive I have it in a folder named quantum glasses. So here we go, and this should take me to the quantum glasses. Now uh, the name of my uh, environment environment was quanta. So before, if you have not created it, just you can simply create it using this command here. So you can just copy it and just paste it here, whatever the name you desire to give your environment. Just make sure one thing, that you make a Python environment with the version Python 3.8. That's the only difference, no nothing else. Because Qiskit might just cause little problems with 3.9, so it's better to go with 3.8. Now, if you, I am assuming that you have created your environment, and if you want to check if you have created or not, you can just type Anaconda Navigator. You can see here. Just open this, click here, open, and it will open. It will take some time, so I've already kept it open. So once it opens, it will look something like this, and you can see here applications on base root. So if you just click on this drop down list, you can see here there are two other virtual environments. So this is the list of all the virtual environments that are created in your system. So this is the by default base root, and these are the other two. As I told you, Quanta is the one that I use to create the project that we are working on. So if you have executed the command properly, you should find your name of your environment here. If the name isn't here, then there's some problem for sure. Okay, So if I am hoping that you have your name here. Now once you have your name here, the name of your virtual environment in this list, you can activate it here. So this is the directory where I created, and you can just conda activate and name of your virtual environment, in my case quanta. So you can see in brackets it's written here quanta. It means that I have successfully created the virtual environment and it is now activated. So inside this uh, environment, I will first install Qiskit, and for that you can just go on this page. See, this is the command that we should use. Just copy this. You can use this one. I don't think it will create problems, but since our purpose is for visualization, especially, so we can just go with this one. Again, just paste it here, and you should click enter, and this will install everything. I'm not doing it because I already everything installed. And after you have installed Qiskit, the next step is to pip install tk. This will install tkinter, and once both the so it will just show some downloadings and all. So once you have done that, uh, you can just deactivate your environment, and you should just you can just get rid of this from. So wherever you have your environment, just go to it and open it with your editor. I've opened it in Visual Studio Code. So after that, you can see here, this is our file that we'll be working on in this tutorial series. So once you have this, just import Qiskit and import tkinter. If it shows, just run it. If it shows you any error, that errors like module not found, then just realize that you have not installed the modules correctly. So generally the error will be module not found, and that error indicates that either you have not installed the installed the packages inside the environment, or you have not given the path to the environment variables, either of the two. So that's one thing, and I hope this is fine because I think I've covered almost every point, and the video that I gave you in the last video in the description, I think that would have helped, and there should not be need for this video, but the only reason was to make this video that even if someone is struggling, that I can just help a little, and I think it should be enough. And learn to work in the virtual environments. It's really important handling all these things. So I hope I think that's it for this video, and I will see you in the next one. Thank you. Hello YouTube. So welcome to the fourth video in the series, and here I am hoping that you have already created your virtual environment and you have successfully installed the required packages. So once you are done with that, we will in this video uh, we will do two things. The first one is we will just create this window, the main window that you see with all these buttons inside it and this frame, this entry. Uh, we will just create this window. We won't do anything of inserting the buttons and all in this video. It will take some time. So uh, as of now, in this video, we will give this title, this logo, and create this window. So when we will run this file, it should just pop up. A blank window should pop up along with this quantum glasses name and this logo. The logo that you can also see comes here, uh, in the here, and is that indicating the app is open. So before we dive into the code, you should have your icon file ready with you. So let's go here on so this is the site that I have used to get my icon. Link will be in the description, so you can just click on the link and check for yourself. So you can see on the left side here, they have a lot of stuff. They have a lot of images, these logos, military messaging and media controls. So I've used this logo. So let's have a closer look at this one. Loading, it will take some time to load. Uh, so once you get your logo, you should download the file and move it to the directory where you are creating your project. So, but before you get your logo, there's a little thing that I want to tell you. So, whenever you just take up a logo, just think a little about it. Just don't choose anything randomly. So, the logo I have chosen here, it is two frames that sort of indicates the two possible states that Qubit can take, like 0 cat and 1 cat. Don't worry about if you don't understand it, but I am just giving the reason why I chose this logo. So these two frames sort of indicate the two basic states that uh, a qubit can fall into when once observed. And since this is a visualization tool, these classes make sense because we are using this tool for visualization purpose. So these are the two reasons why I chose this logo. So you can just search for a logo that you like and for some reason. So you can just download this file and move it to the folder where you are creating your project. Once you are done with that, uh, you should have something like your main file and this .ico logo.ico file with this .ico extension. So with that, you can we have already imported these Qiskit and Tkinter in the last video. Now we defined this window, the main window that we talked about, this one. So this tkinter.tk is this the object. You can just think of this variable, which is nothing but our window that pops up when you run it, and this is the title that will be showed up. Okay, I've kept it quantum glasses, so you can see here quantum glasses. So this is your title that you give. So let's just comment out everything and just note this command. This is really important. So this actually runs your window. So you can see unless and until I close it, the terminal will be busy. So now it's again free. So now I will just comment this all out so we can just see how it looks. So the multi-line comment, and the shortcut that I used is control plus the question mark key. So this will comment out all and the entire selection. So let me just run this. You can see it here, this little file. Now notice that I can extend it here, and we will fix that too. See, I have not given any logo yet, so it is just this kept this by default logo of feather, I guess. And the title is quantum glasses because that's what we have set. So just let me just close this, and now we will just uncomment this. And the same shortcut key for the uncommenting these lines. So here we set the icon. So in the default, you keep this the name of your file. So in my case, the name of the file was logo.ico. So I kept that, and the default is the reason that when we will also create windows inside these windows. For example, for the our about button that we will create, there will be another window that will pop up when you click on the about button. So the logo of that window will also be this logo file. So to keep that, I keep the kept default is equal to logo.ico. And in here, this is the geometry. So this is the size of the window basically. So 399 by 410, and you can just initially you can set 400 by 400 or 500 by 500, and you can just adjust later the way you like, uh, the way you find it to seem to look better. You can just change the numbers later on. And here is one important thing that you should notice: root dot resizable 0 cross 0 comma 0. So this means that uh, I will not be able to resize. So let me just show you. Just comment this one, and I will run it now. Save and just run this one. Notice our logo has popped up here beside the name Quantum Glasses. And now if I want, see, I can just change the size in both the directions. This way. But I don't want that to happen because it can just affect the way I've set up the all the buttons and the screen. So it may require additional coding, and to avoid that, and to avoid any possible error, or maybe something like buttons and not a may just disorder a little here and there because of this resizing feature. So what I will do, I will I'll just keep this root dot resizable 0 comma 0. So this denotes x and this denotes y direction. So if you want to block the resizing feature in x as well as y, you can just do this root dot resizable 0 comma 0. And now if I run this again, you can see now no longer I can resize. The size is fixed now. I can do nothing. So this is a very important command that you should know. Now let's get back to this. So these are just some fonts and hexacolor code that we have just kept into variables. So these are the variables. These are Python variables. This is a string that you can see here. Here different types of variables: integer, like normal numbers 1, 2, 3. Then we have float point variables that are like 2.3, 3.0, 4.5. So such numbers float, and these letters, and these the which can be inside this single quoted marks or double quoted marks. And the other type is the boolean variable that can be either true or false, and you can just set it like this. See, for example, for integer you can just keep 1 like this, or for float like this, 2.4 maybe, and for boolean you can just keep it true. This is a boolean variable now. So These are some important type of variables that you would like to know. But know that these all here in our project, these strings just denotes some colors that that will be using to color our buttons and the entry screen. So how do you get to these colors? So you can just go over here and see we have site called image color picker. So just go there and it will ask you to choose an image. So use your image, upload an image in the in quantum glasses. I have this image and open. So you can immediately see that with respect to my image, it has shown me various colors that I would like to use in my project. Right? I have a lot of choices here. Try to experiment with these. Various choices. And whenever you think like, yeah, this is a good color, so you can just copy it. See, copy it to clipboard, and you can come over here and just paste it here. So that's how I have chosen these colors. And the other two here, these are just font. So this is the font style and this is the font size. So as you can see, for the main project, let me run a main project file. So you can see this font and this font size. So to decide that what should be the font size, we have just stored it in a variable. So we can use it. You can just use the variable whenever we need the use or when you need the value for a particular font size or for a color. So that's it, I think, in this video. So if I go back here, again, let me run this. So this is our file. So you can see our window pops up. We have the title, we have the logo, and I've shown you the resources that can help you to get your logo and your uh, color picker to uh, choose your favorite colors for your project. So I think that's it for this video. In the next video, we will try to work more on the layout, see what should be the way of working and how you should plan out the layout. So I hope you liked this video. So now we will start our project, the main cool stuff. So thank you. Hello YouTube. So in this video, we will try to understand our layout and we will define the frames uh, and we will pack these frames to our window and give the required color and font style, etc. So let us begin. Let me just show you the main file. So just run this main file. So this is the main file. So here you observe that these we have two frames here. The first frame consists of this display that you can see, and the second one consists of all these buttons. So we have two frames, namely display frame and the button frame. So these two frames will be creating today in this video, and let's see how it goes. Okay, so how do you define a Tkinter label frame? This is how you do it. So Tkinter dot label frame, and you pass the name of your window. So the name of our main window is root. So where do you want this frame exactly? So we want these frame in the window root. So that's why we pass the root as a command. And see, now we have this another frame, button frame, that will consist of all the buttons that we will be using. Then we will pack these buttons. So what does pack mean? Pack means that you are inserting the uh, some elements into your window. So there are two methods to do this. The one is dot pack that we are using here, and the other is dot grid. Both of them works in different ways. When you use dot pack, it just attaches your element into the window the way the space is available to it. And the third thing works like the other method dot grid. uh, it uh, it is works in a more systematic way. So it works on zero row, zero column, and that way. So it uses row column way of assigning elements to the window. So that's one way of working, and the other way is using this dot pack. So know that for frames we can just use dot pack. We don't need anything else. But while you're working within a frame, so shortly we will be inserting various buttons in the button frame. So while doing that, the one thing you should remember is that if you use one method in one frame, you cannot use another. So if you're using dot grid, remember to use the same method in the entire frame. If you don't do that, you will get errors. So just stick to one method in one particular frame. So once you have done, see in this button frame, we have this extra attribute. We're given this background color is equal to black. It's just a way of differentiating the two frames so that I can show you that the two frames are different. And again, this fill equal to both means it takes over the entire place. Expand equal to true and fill in both the directions, so it will be clearly visible to you. And now we create the display frame. So this is what you see when you actually type a button. You see the which button you have typed. Let me show you here. Just run this file. So for example, if I type H, you can see H. So this is what I'm talking about. This area, this display is nothing but this display tkinter dot entry. So this entry is nothing but that display frame. It is display what you call it, and then these are the various attributes for it. So where display frame indicates that we want to attach this display into the display frame. The width of that display should be 120. Then what should be the font about the things which are displayed? So for example, again, let me open this. So this has a particular font style and font size. How do you want to express it? So remember in one of the videos previously we talked about these variables. So now we use it. So the font will be display font that you can see. Again, you can vary these font style as well as this font size. So it's your choice. You just run your program. If you don't like it, change it later on. You can change it anytime, and that's where they are using it as a variable. So anytime you change it here, and it changes everywhere. So for example, we will be having a lot of buttons. So directly I change the button font, and every button's font will be changed with that. So that's one of the advantages of using variables and why we use variables. Now again, this is the background, and this background is nothing but this. The color that we have defined here. So remember, this is sort of blue color, and the tool color picker helped us to use to get to this color that I have showed you in one of the previous videos. So, and the border width is the width of the border. I'll show you when I just run this file. And then we have justify equal to left. It's just a justifying alignment you can think of that we have in Word. Left is a keyword. And what are keywords? Sort of keyword you can say. So I need to import it from here. From tick enter, import left, and I can just keep it left. Now, what are keywords? Let me show you in another file, new file, and what I will call it, I guess. Okay, so there are certain keywords that you cannot use for your variable names. So that's the main point. So for example, we have a method def, keyword def that we use to define a method or function you call it. So these uh, the keyword def stands for define. So we use this to define the function in Python. Another one is, for example, class. Class is also a keyword that we use to define a class. So for example, main class or something like that. But we won't go into the OOPS concepts, the object-oriented programming. I just wanted to tell you that, for example, let me just define this as try to define it as a float or maybe just integer maybe. And if I try to run this, it will give errors. Just a second. Okay, I have the other thing running. See, syntax errors. These will show you errors. So whenever you use a class defined keyword as your variable, so this will give you error. And so you can see that your editor will highlight this as a different color whenever you use a keyword. So if I just use classes, which is not a keyword, you can see the color has changed. This is a valid name for a variable. So if I run this now, see, it run very well. No errors, no syntax errors. And again, you cannot use some special characters like this one. See, it's error. You can see it's showing the red line. It's error. Or numbers in the beginning, that will be error. You can use it later on. There's no problem. But you cannot use in the beginning. Or you can use it here. Underscore is a special character that you can use. But again, this is a different meaning. So that won't go into the depth. So this is I want to talk about the keywords that you need to know. Let's come to our main thing again. So again, once we have defined the element, we have defined our display screen here using all these attributes. Now we will pack. So we will insert this into our window, and pad x and pad y are just spacing in x and y direction for the entry, and you can experiment with these numbers. I really encourage you to experiment with these numbers so you can get a better understanding of what's going on. So let me just run this. So you can see it here. The background is black for our frame, and this is the screen. We don't have buttons so far, but we have this border width. This x and y padding looks good, I guess. So in the next video, we will go into the detail and we will see how to get a button, the various functions that are required, and etc. Let's see. I hope you are excited for the further project. Hey there. So now we will start with the quantum physics part. So the most exciting part, I guess. So before we start coding the buttons in the button frame, it's good for us to, have a look at all these buttons. What do they mean? So if you can see here, in this button frame, we have a lot of buttons and we have two categories of buttons. One is these buttons that you can see, which are the actual gates, quantum gates. They, all these buttons here, X, Y, Z, R, X, R, Y, R, Z, S, S, D, T, T, D, and H. All of them denote quantum gates and they perform these operation of quantum gates. So I call them quantum buttons, and all the buttons that you see here in sort of light pink color, these are the second class of buttons that we have, and these are just sort of utility buttons or for user comfort. So let us understand the functions of these buttons before we dive deep into coding, so you know what you're doing. So before we will code all the buttons, I will tell you what are the functions of all these buttons, what is the quantum physics that goes behind all these. So, and before we will start coding these buttons, you will be having some basic understanding of all the single qubit gates and all these buttons and what button means what. So, let's first talk about all these buttons. The four buttons: quit, visualize, clear, and about. So about button, let's click here. So you can see here, what is this? You can see the logo. The first thing to notice, we have the logo the same as our main window. And if you remember from the previous video, I told you that we were setting default is equal to logo.ico, and this is the reason. So even if we have any other window that pops up, it will be still this. You can see we have a few options here, nothing to worry. Then the title is about. Now the same way we gave quantum glasses to this window, we can give it to this. Then this is the text, that sort of heading that we give about quantum glasses. So this is a visualization tool for single qubit rotation on the block sphere, and this is created by me, Jay Shah, and we have used Python, Tkinter, and Qiskit for this project. Now we have all these buttons and their definitions along with these uh, the the commands that you can see use. So on this, in this column, what you see are the commands that you can use to uh, apply these rotations. So all of these buttons actually apply rotations, and then we'll see in detail what all this means that you can see on your screen. The special note for these X, R, X, R, Y, and RZ buttons, and we will also see error handling, and this is related to that. And another note that we want our users to understand. So this about quantum glasses, this about button just displays this text, this complete text. So this whole window will give the entire overview of the project to the user. So when a user is using, he knows what things means what. So for example, flips the state of qubit when you use this X gate. So we are just given the function of a particular gate and the command you can use. Again, you don't need to worry about this. We will be seeing this shortly, what everything means here. And now just let me just close it. Gone. So that was everything about the about button. Uh, and now let me get to the clear button. So let's see. I have just uh, applied a few gates. I'm trying to visualize something, but after I completed this visualization, I want to visualize some other set of operations. So I don't want to close the window and then again run everything, again run the program for a next visualization. So that's why this clear button comes into the picture. So what this clear button does is it clears the screen, very obvious. And the other thing that it does is that it reinitialize the circuit to the initial state. So when we apply all these commands, there are various operations that goes on, and it changes the state of the circuit of the qubit. So when we press clear, it also brings the qubit back to its initial state. So these are the two functions of the clear command. And then we come to the visualize button. After the clear button, we come to this visualize button, and it is the most important button in the entire project. So say for example, I press these two buttons, but how I visualize it. So we click on visualize, and another pop-up window will come up. It will take some time responding. It happens. There we go. You can see it here, these rotations that are going on, and it's okay if you don't understand this. So it goes here. So this is the rotation, and you can see you save the figure. You can just you know drag it here, everything have a better look. But that's all, and reset original view. So get back to the original view. And this functionality is provided by Qiskit. So we what we will do is that you use that already provided functionality, so we can just build over it. So visualize button has only one function, that visualizes everything you see, just that. And another button here is this quit. So once you have visualized your circuit and you want to close this application, you can click on quit. Gone. So it closes the application, it aborts it. It's done. uh, so that was four buttons. uh, Let me show you again the project. Yeah, so in this video we saw the function of these four buttons. About displays the info about the project. Clears the clear button clears the screen, and it reinitializes the circuit to the initial state. Visualize button helps us to visualize the circuit that we have typed, and the quit button just closes the application. So these are the four buttons that we have seen. In the next video, we will see some buttons in some of these buttons, and see what is the math behind the mathematics that drives these transformations, and how we use Qiskit for it, and we will visualize it too. So let's see you in the next video. I hope you like this video, and the most amazing stuff will coming up in the next video. Thank you. this video, we will look at the X, Y, Z, and H buttons. What are these? What are these gates, and uh, what they do? What is the mathematics behind them? What are the basic states? What is direct notations? All of that in this video. Uh, so let me just clear this first. So let me go to the Qiskit documentation. So this is the textbook of Qiskit that introduces you to some of the basic things from basics up to the advanced things. So what you can see here, this is the X gate. So note that all the gates you see, uh, as you can see here, all these gates are actually denoted by a matrix. All of these gates have their own unique matrix that denote them, and I can minimize this. So similarly, this X gate is denoted by this matrix, this 2 by 2 matrix, 2 cross 2 matrix with these 4 entries. This denotes the X gate. So uh, initially, a qubit is in this state. This is called a ket, 0 ket, and this is just this vector. So so this and this is the same thing, but the way of writing is different. So this is how you write this vector in the direct notation. These are called direct notations. So this is called 0 ket, and this is called 1 bra. So this is the bracket notations, or the direct notations as we say, and these actually these 0 ket and 1 ket form the basic states. This is the states in the computational basis. So this is think of it as a computational basis state on the z-axis. You will see shortly. So let me just click this X and visualize. So it started here in 0 ket that you saw here, this vector, and it should end up here according to this mathematics. Should end up here. It ends here. So when you apply X gate, it transforms this 0 ket into this 1 ket denoted by this direct notation. So this is also simple vector with two entries 0 1, and the other one was 1 0. This was 0 ket and this is 1 ket. And what happens is when you apply X gate to 0 ket, initially every qubit is in the 0 ket in that state in Qiskit. So when you just start your function, initial state is here. This arrow this is pointing here, and as soon as you apply the X gate, that transforms that vector into the 1 ket. And this is the driving mathematics. Simple matrix multiplication. The only takeaway is this matrix that it denotes and this operation. So you should ask me what happens when I apply x to 1. It will be the converse. So let me just show it. Let me just close this and clear. So when I apply x once, we now know that it will transform the 0 ket state to 1 ket state. So let me apply this again and see what happens. So I will visualize. See, it's applied, and let's see what happens. So previously it stopped here, but this time it won't. And let's see where it goes. And see, it gets back here to the initial position. So what it means, It means that when you apply X to the 0 ket, it transforms the state to 1 ket, and when you apply the X gate to 1 ket, it transforms it back to the 0 ket. So that's why we call it the bit flip gate. So if I show you, flips the state of a qubit, and this is the command that we use uh, for it, just .x. This circuit is the instance of quantum circuit class, and we will see what is this class later in one of the videos. But we realize that this circuit just denotes the quantum circuit, and we just apply X gate. So this is the entire command that you use to apply X gate in Qiskit. So let's close this. Let me clear. So we are back in the initial state now, and this is the symbol in Qiskit that you can see. So you can see it here, and as expected. So that's just what we saw. So let me apply Y, and let me visualize what happens. So it's going, and it stops. It stops on 1. But realize that the plane of rotation was different in the two cases. Let me show you again so you can keep a watch this time. When I apply X, see the plane rotation is perpendicular to X axis, this plane, right? And okay, we are done. So I'll clear it again. I'll apply Y and I will visualize. This time we are moving in a plane perpendicular to the Y axis. So whenever you apply a gate, X or Y or Z, the rotation happens in the plane which is perpendicular to that axis. So again, we ended up in this one state. Let me let me show you the mathematics that drives it, Y and Z. So this is the matrix that denotes it. This denotes Y and this denotes the Z. Let's keep Z apart from for a moment. Uh, Y gate is denoted by this, and it will also end up in the different in the one ket. But you can see here. Let me just scroll a little up and see there's the difference in this denoting this X gate. So this is how you express it in another format. It is the same matrix but being expressed differently. And if you see by, there is a difference in the way of representing. We have this I here. This is called relative phase. We will see that, and you can think of this as a sort of reason that differs. So you can see here we don't have one, we have minus I and I. We have complex entries here. This I denotes a complex number. So complex number is A plus IB. So A denotes the real part, the real number, and plus IB is denoting the imaginary part. So B is the imaginary number. But both of them actually are part of this state. So you can see X was denoted by these all the real entries. We had the 0, 1, 0 and 1, 0 entries, but here we had complex entries minus I and I. So this can be thought of as a reason why the rotation was different and why X and Y are not the same gates, though they end up so despite the end result was 1 ket. So again, let me get back here. Let's see what happens when I apply this 2 times. Let's see. 1. Here we know that would happen. Again going up. and it should be 0. So again, we see that uh, the same thing happened. It again got back to 0 cat. What happened by applying x gate twice, but the rotation was different, and x and y are therefore not the same gates. So I'll just close this, clear this, and you can see this Z gate. Again, this is the difference, right? Now, if I apply a Z, the rotation should be perpendicular uh, in a plane which is perpendicular to the Z axis. So let me see if something happens. Nothing happened. Why? Because it's not possible to move in the Z in this plane perpendicular to Z axis, because this is the Z axis that you are seeing. So we first need to get into the into this plane if you want to see Z in the action. So let's keep Z aside and talk about another gate, the H gate, denoted here, also known as the Hadamard gate. So Hadamard gate is denoted by this matrix, and when you apply to 0 cat, it ends up in plus state. What is this, we will see. And when you apply it on one state, it will end up into this. So let's see what is this plus and minus state. Just a second. So initially our circuit is in the 0 cat state, we know that. So let's just apply this, then we should end up in the plus state, plus cat state, you can say. Visualize. See, we are moving here, and let's see where we end up. So this state that you can see here is called plus state, and is actually a superposition of 0 cat and 1 cat. So it half 0 cat and half 1 cat, as you can see here, right? It's in the midway of both the states. And also realize that now we are in this plane, Z plane, in the plane which is perpendicular to Z. So now if I apply a Z gate, something should happen for sure. So let me close this again, and let me clear this. I apply H, I apply Z, and now something should happen. So we know that it will end up in the plus state here, nothing surprising. Let's see what happens next. And now you see the rotation is happening. So this is how Z gate works. So I hope you got a good visual understanding of these gates. So the rule of thumb or the takeaway is that the rotation will happen only if the state is in a plane which is perpendicular to that particular axis. And these gates just make a x, y, and z rotate the vector if it's in a plane perpendicular to the respective axis by pi radians. So 180-degree rotation. So applying twice gives you 360-degree rotation, and that's why you end up on the same thing where you started. So if you apply on 0 cat, you apply x twice, you end up where you started. And that's the reason, because a 360-degree rotation will definitely make you land where you started in a sphere. And what is this sphere basically, that you might think? This is a block sphere, and this is a way of denoting the states of a qubit. We will go into details later, but think of it that this vector that you colored vector that you are seeing is just denoting a state. This is the state of the qubit right now. So, and it denotes how the transformation is taking place for that particular qubit. So I hope you like this video, and in the next video we will see these remaining gates. Rx, Ry, Rz, S, Sd, T, Td, and what do they mean, what do they do, what is their functions. We will see that in the coming video, and I hope you have understood what are X, Y, Z and H gates and how do they work. If you think you have not understood the mathematics deeply, so it's okay. I'll be trying to come up with a series where we will just focus on the math. But here you know something yet, like how these rotations happen. And once you complete these series, this series, first series, you will be having a tool that will help you to experiment. So you can just freely visualize whatever you want on the block sphere, and we'll go into the details of quantum mechanics later after we complete this series. So so it will be you will be able to visualize everything much more easily when we will talk about math. And I know we have talked about math in this video as well, the various metrics, and it was just simple matrix multiplication, but we will go much more depth into much more depth in the a separate series on quantum mechanics, where we will talk about the different phases and what are density matrices, what are various, we will talk about various quantum algorithms and some interesting uh, stuff. So I hope you stick to the channel in this series. You also come back for the other series. Uh, so that's it for this video. I think this video is pretty long. So I hope you like this visual representation of all the single qubit gates. Thank you very much for watching this video. Hello YouTube. So far we have seen the X, Y, Z and H buttons. What are their functions? What gates do they denote? And what is the driving mathematics? So in this video, we will see the S, SD, T, TD, and RX, RY, RZ gates. So, and what are their functions? What are these gates? We will see that. So, as we saw in the previous video, let me show you again. I forgot to show you this. So this is the plus get state. This is the superposition. We saw that when we apply Hadamard gate, it hangs between the 0 ket and the 1 ket. So this is mathematically how you can represent it. This is that state, and we saw this transformation here, how it happens. And now we'll jump on to the S gate. Let me show you this. So this is the matrix that denotes the S gate, and this is the S dagger gate. S dagger is sort of just inverse of the S gate. So you can nullify your S rotations that you do with your S by S dagger. So as you can see, this is root. We call it root Z gate with a rotation angle as pi by 2. So what Z gate does is that it rotates the state vector by pi radians in a plane which is perpendicular to the Z axis. Now what our S gate does, it rotates the state vector by an angle of pi by 2. Pi by 2. That's the only difference. And S dagger will rotate in the opposite direction by pi by 2. So let me show you again. So we know that if we directly apply S gate, it won't work because initially our state vector is not in a plane for perpendicular to Z axis. So to bring it in the in the plane perpendicular to Z axis, we'll first apply a Hadamard gate, and then we apply S gate. And let's visualize what happens. So see, so far we have just H. rotation is going on, and now you see we have S and it is rotating, and we end up here. This is pi by 2 rotation. Now what would happen if I use S dagger instead of S? Let me close this, clear. Again, it's mandatory to use H to get the state vector in the plane perpendicular to the z-axis. Now I apply SD. So SD denotes this S dagger. Now let me visualize. Again, the Hadamard rotation is happening, so our state vector is coming in the z plane perpendicular to z-axis, and now you can see it's in the opposite direction. Rotation on the same plane, but by pi by 2, but in the opposite direction. So you can nullify your S gate by SD gate. So let me show you. So I will clear it again. If I apply H, then I apply S, then I apply SD, then it should return us to the plus ket state. So that superpositions, initial superposition state. So these two gates should have no effect at all. Let's see if that happens. Initially we are getting here, we will be getting here in the plus state. We know that, we have seen it a lot of times in this series. And now we apply S gate, so it should end up here. We know it. So it will get here. And now S dagger. So it's rotating in the same plane by pi by 2, but in the opposite directions. So we should end up here. So that's it. So we have nullified the effect of S by using S dagger gate. So let me close this, let me clear this. Now we move on to the T gate. So T gate is a very commonly used gate. It's pi by 4. Same story goes here. This these rotations take pi by 4 in the plane perpendicular to the z-axis. So again we need to get to the plane perpendicular to z-axis. So first H is mandatory. Then I will just use T and I will visualize. So you notice we are just getting to the plane, and now it should end up somewhere here, somewhere just here. See, it has stopped 45 degrees, pi by 4 rotation. And now if I use T dagger after using T, it should nullify the effect because it will move by pi by 4 but in the opposite direction. So let me clear this, apply H, T, TD, visualize. And we know we will end up here somewhere in 45 degrees because of the effect of T gate. Now we are moving in the opposite direction because of the T dagger. We are moving here, we are moving here, we will end up here. That's the story. I will just clear this and minimize this. So you can see this is the matrix. So just notice the difference of this pi by 4 instead of pi by 2. And this is T dagger, the matrix for T dagger. Simple mathematical matrix multiplication, and you can work out the mathematics of what would happen when you apply it to the different states. For example, plus state that we saw. So for example, so this is the case, and this is plus ket state that we applied these Z and T gates, and then applied T dagger and Z dagger gates respectively. So I would be happy if you can just work out the mathematics. This is the actual state that in the vector form, the simple matrix form that you will be aware of. So just try to work out the mathematics, see how it goes, and how these changes take place. You have already seen the visualization, And what are these Rx, Ry, Rz? So if I click Rx, this is a sort of parameterized rotation. So these Rx, Ry, and Rz will rotate the state vector in a plane perpendicular to their respective axis by a given input. So these x, y, z, s, t, td, st, all of these are some special cases of these three gates. So uh, if you choose a negative angle here, as you can see, then it will be like a dagger gate. If you choose a positive angle, it will be like S and T gate. For if you use pi, then it will be X, Y, and Z. So since I have used Rx here, it will be like X. So if I see, I have these 8 buttons here, each having different value, and this shows that we have these the range of values. So if I do pi, then it should bring us to the one cat vector state, because initially our state vector will be in the 0 cat, and we should get back to 1 cat. So let's see pi, and I will visualize. Or we can see our angle here, angle, and we should be ending up in the one cat state. That's it. So this is what our X gate does, and quickly we will see again. I will do pi, so it should be identical as the Y gate. So the all the X, Y, Z gates were just special cases of this RX, RY, RZ gates, and close this, clear. Now if you want to use RZ, we have to first use head, and again I will just use pi, visualize, and our state will be in this plane. We've got into plane, and see now a rotation by pi radians, 180 degrees. So that's it. So now let me summarize all these buttons for you. So these four are the user buttons for user comfort. About displays all these information about the uh, about this project. Clear buttons clears it and clears the screen and reinitializes the state into the 0 cat. Visualize button just helps you to visualize. Quit button closes the application, and these are all these our buttons that denote specific quantum gate and applies to a specific single qubit rotation in the block sphere. So I hope you have a general idea of what's going on, what are these gates, what do these buttons denote, what is their significance, and I really encourage you to go to the Qiskit textbook and read to get a better insight uh, of what's going on if you need. I hope this was sufficient, but if you want to refer while you are doing some mathematics that I told you to do, you should refer this Qiskit.org textbook. It will help you, and I think that's it for this video. In the next video, we will go to work with our button frame and insert various buttons. We will see how to insert button, how to give functions to this. We will also see the corresponding Python concepts that will be required. So I hope you are really excited to build this project after you have had a glance of what this project actually is. So thank you, and I will see you in the next one. Hello. So so far this is what we have done. We got this display. We have created this button frame with the black background so we can differentiate it. So what we will do in this video, we will try to now pack buttons into this. We will start inserting button into this. So let's see how that's done. I will just uncomment this. So first of all, you have to define a button, take enter button, and that you do using this way, take enter dot button. So this will create this X gate button. Then of course you have to define in which frame you want this button. As we have already created a button frame, and we will pass this. So we will say in the button frame we want this X gate button. Then we will give the font for this button and the background color for this button. So this is what we have defined previously, buttons and this button font. You can vary this definitely as per your choice. And now text is what should be displayed on the button. So when the button is actually being inserted into the frame, what should be displayed on it? So I have chosen I have kept X because that's what represents the X gate. Uh, and after we have defined all these three buttons, so here we are defining the first row of the buttons in our visualizer. So after we have defined the buttons, it's important to uh, insert them into the frame, and for that we will be using the grid command. As I previously told you, there are two commands for it, dot pack and dot grid, that we can use. So here if I just comment it out, you will notice that nothing would happen. Let me run this again. You can see, though we have defined the buttons here, nothing is visible over here, right? Let me close this again. And, okay, so now I will uncomment this. So now dot grid method, as I previously told you, uses the row and column format. So the very first place which is empty will be considered as origin, like 0 comma 0 was 0th row, 0th column, and then we can vary the values for row and column, and we can insert it that way. So you can see here that for all these three buttons I have given the same number for row, so they are in the same row and different columns. This I paddings, these are just internal paddings that you can give the way you like. These are the internal paddings in the buttons in the X direction. We also I pad Y, but I did not give that. These are the external paddings, pad Y. And notice this important parameter here, sticky is equal to E. So here, this E stands for east. So sticky actually makes your button stick to one of the sides. So let me just do this. Let me just remove this and see what happens if I just run it now. Looking fine, but okay, we have see where we are X, Y, Z. Nothing will happen right now because we need to give a few functions for buttons to display and all, but we will need some background math, Python for understanding that, and I will be covering that in one of the future videos soon, maybe next one. So you can see we have our buttons here, and applying sticky won't be a big issue here because this is the first row. So first row takes the entire place. So it's okay if you don't apply yet, but I just wanted to show you the command. Sticky actually sticks the particular button into that direction. So it just helps you expand it. Maybe I can show you in one of the future uh, buttons that we will insert. Let me just change this row now. Let me show you if I change the row to y of y get to row number 1. Let me show you what happens. As you can see here, the row has shifted here, row number 1 and column number 1. So this if I apply row number 1 and column number 0, it will be beneath here. But since I applied row number 1 and the column number 1 2 is lying in the middle here. So that's one of the, and that's why I actually like the grid method. It gives you more control. uh, okay, I'll put it now. Let me just bring it back to first row. Now similarly, one by one, I can just insert all the buttons here. So let me just copy it from the main file. These are all the buttons that we have seen so far, and you can just copy paste it and just change the, like, I will explain you this. So we have all the buttons now. See, this is command attribute, and just omit it for now. Just select this, and if you see, all the command here are selected. So if you press Control Alt L, it will not work. Control Shift L, yeah. And if you press back, we have all the cursors simultaneously working. And if I control this, maybe I can control all of it now, right? Control Z. Uh, Let me keep this for right now because this is an important command. So this actually shows our button which command they are supposed to follow. As of now, this doesn't make sense because we have not defined any functions that it can work with. So this is the second row of buttons. Another shortcut is if you use Control Alt and down arrow key, you can have again this multi-line cursor, and see, I can just do this. The same thing goes with this one. Let me just clear this so I can just show you the uh, our completely full uh, visualizer. Otherwise, when I run it will give me error that this is not defined, that is not defined at all. Command visualize. And I think we should be good to go. As you can see here, for each row, I've just changed the row number, increased the row number, and keep varying the column number as 0, 1. Now, sticky is just used, as I told you, to stick your button to one of the directions. west or east or north. North means up, south means down, west means to the left, and east means to the right of the frame, right in the frame. One of the another important things that I want to show you is the column span. So column span is the number of rows that a button can use. So previously we saw that uh, it was just changing its one row one by one, right? So if you want, you can make a button use two rows. So we had the buttons X, Y, and Z. So if I had changed the row of the button Y to 1. So if I wanted, I could have given it a column span 3, and it would be spanning the entire row. So that's one thing that I want to tell you. Let me show you if I can just do this. And so we will again only have this one. Again, look, I will just do what I had done previously, and now I will give column span 3, and I will be able to see it what this column span means. Okay, look here. Now this that's why sticky comes into the picture, because it has completely come here, and the Z has shifted here because it was empty this side. So now let me close this, and give sticky equal to east. Sticky equal to east. It doesn't work here. Okay, because we don't have anything here. This is the max thing that we have. We don't have another column here at all. So let me close this again, and column span, and let me give sticky to this. Then my PU will be able to see the change. Just play a little with it. Now see, here it has occupied the entire thing here, the entire column, right? It did not work with that because it was itself the entire column. It was the biggest button, but that was not the case with Y. So when I gave it this sticky west to east, it took the space in the entire column from west, that is from left to right, the complete space. If you can just go back into the video, you will be able to see what was the difference. Again, if you're not clear with it, if you have recognized the difference, it's all good and fine. So let me close this, and I will undo all my steps. So column span did not work properly, I guess because of that issue of the row and column. But let me show you again. And there we go, everything packed. You can see here that about button is going down little, so we can change the size of this main window, or we can decrease the padding here of this column. Let me uh, increase the height of here we have maybe 20. I'll run it again. mm, no, we need some more, I guess. What about 40? We have just crossed the required size. Little adjustment will take time. 430 maybe. Almost good. Just one. I think this would be the final one. Yeah, this looks good. Maybe you can just do one. You can reduce a little one. Maybe I think this looks good. So you can see here we have this clear button that spans over this entire three columns. So if I just show you for the clear button, it's defined here. You can see column span equal to 3, stick equal to western. Let me just keep column span equal to 2 and let's see what happens then. I have not closed it. So saw that it was taking the entire three columns, and now I will decrease the column span. Let's see what happens now. I just wanted to show you what column span actually means. See, it has just reduced to two columns. These two columns, it has restricted itself to here, up to the two columns, because I've reduced the column span. So that's what column span means. You can use these while you start working on your layout, and I really encourage you to come up with a different layout than mine. Plan your layout on your paper first. Think of all the buttons. If you want other buttons, you can check out the Qiskit.org textbook. Maybe you can get some ideas from the official documentation also that they have. And the two things that you can use is in this dot grid method for adjusting your layout is this column span. We also have a row span that I think I've used for the header margin. I should be explaining with this while keeping the visualizer with me. So you can see here this header mart gate spans for two rows and one column and two rows it's taking. So similar to column span, we also have row span. So you can give row span equal to 2. By default, it's just 1. So when you give it to for 2, it will take 2 rows. That's what I've done for header mart gate. And now for clear, I have not changed the span. Uh, that's just one thing. So I know I have not I have not gone line by line with this button packing, but I think you should try it by yourself so you can get some idea. I already showed you how I packed the first three buttons. If you get stuck somewhere, try to search online, your get your errors or if your solutions to your problems or whatever you're facing, if any you face. But I really encourage you to come up with a different layout than mine, so that it will help you in planning, like how to go ahead. I think that's it for this video. So in this video, we have our layout. Spend some time, try to come up with a different layout, maybe the same one that I have. Try to code by yourself. I don't. The only thing I have not gone step by step with all the buttons because they are just same. Like you just define a button. There are only two steps, three maybe, to define a button using a tkinter dot button here. Then you insert that button using this dot grid method, and there you define the row number and the column number. Then you can define column span for how many columns you want to span that button. A row span if you want, for how many rows it should span. And sticky is another thing that will stick the button to those particular and in those particular directions of the column that it has the button is in. So these are the few elements that you should keep in mind while you are working with your layout. I think that will be enough. Just remember to give background color, give font to the button, the frame which it is you want your button to be in, and the text which should be displayed over the button. And that's it. I think that will be just fine. Maybe you can watch the video again. You have the code here in front of you. You can just take a little look at it. See, in header mart, I've used sticky WENS. So that is west, east, north, and south. So in all the directions, I've just stick it. So it will take complete place. Uh, Now, the other thing that we need to do is we need to define functions that will be executed by these buttons. So far we just have buttons here. You can see we just have buttons, but they don't do anything. Yeah, I can click it, but these buttons don't do anything. So to make them do some task, we need to define functions that will guide these buttons on what they are supposed to do. So let me just clear button, column span 3. There we go. So again, the clear button is back, and so we this is the layout is complete now. It looks good. So let's see. In next video, I will give, and in even then next video, in the next two videos, we will talk about some Python basic things that you need to know. List, set, dictionary, what are functions, what is anonymous function, lambda, and what are global variables, local variables. We will be talking about such concepts. So, and it will be required. Some of the concepts are just the basic Python that you need to know, and the other things will be some of the things that we will be requiring to move ahead. So I hope you like this video. It's a longer one, but it's one of the most important part uh, that will uh, I think test your creativity if you try to come up with a different layout, and I really hope you do that. So I'll see you in the next video when we will talk about some Python there. Thank you. Hello, so welcome to this video. So this video is just about basic Python. Uh, the elements that we discuss in this video are not very useful for our project specifically, but these are some basic things about Python that one needs to know at least. In the description, I will give some resources, free resources that you can use to learn Python in depth. But I'm just covering some simple things here. Uh, if you are very well versed with Python, you can just skip this video and move on to the next one. So let's see what we will be covering. We will be covering list, set, dictionary, conditional statements like else and for loop. We have other things, but I'm not going much into it. Okay. So what is list? A list is a data structure. You can think of it like something that holds your data. Let me just show you. So I will just name L1, list 1. And there are two ways of creating a list. The first one is just, this is the keyword. List, I talked about keywords previously in one of the videos. So list is a keyword that will create a list. Other way of creating is just square brackets and add your elements that you want to add. So this list now consists of these three numbers, and if I print L1, just run this, you can see here 1, 2, 3. Now the great thing about list is that you can have dissimilar elements as well. So different types of we talked about various types of variables in one of the video and in this series, and so these values are integer, so I can also add a string here, just my name maybe, and other can be 4.6. This is a float value, this is a string, and if I just run again, you can see we have here output. There's no error. So that's the advantage of a list. You can have various dissimilar elements to working at the same time. So one of the most important commands to know is to add an item to a list. So here you notice we have these 5 elements. So what if now I want to add the another element, the sixth element? So the only thing, a simple thing that I need to do is L1 dot append, and I can add anything, say 8. So now I print it, and you can see here at the bottom I have 8. I have 8 here in the list. So another way of inserting an element through index. So indexing is the sort of way of fetching values. So the indexing starts from 0. So if here I just print, now how do you index it? Use square brackets and you give index. So 0 means that this is the first element here, the integer value 1. So it will print 1. I'll show you. You can see here 1. Similarly, there are also negative values for index. So you can use negative values as well, and it will start from the last element. So if, and this time it starts from -1. So if I take -1, it will give me the last element. So yeah, 8. It was my last element in the list. Uh, so these are the two ways way of indexing. Again, we have a concept of slicing. So 0 to 2. This is a way of slicing index from 0 to 2. And you can see we have got only first 2. And the reason is that the value you give here is excluded. It's not included in returning the value. So if I give 2 here, it means I want values up to index 1. So it will give me 1 and 2 of our list. And that's what we get here, right? So another way of inserting element in the list is the method insert itself. So let me just clear this. Append insert. Now let me just so now again we will add the value 8, but before that we will specify the position at which we want this element. So let me run this again. the list. You can see here at the bottom that now 8 is at the first position at the 0th index, and 1 is shifted to the first index. So this is another good method that you should need to know. And the next one is the remove. Like now you have you know how to insert elements, but how do you remove elements? So say we have already this element 8 in our list, and now we want to remove this element. So it will be remove 8, and that should work fine. So you can see here we no longer have 8 in the list. It's just up to 4.6, though I have initializing in the initializing step of the list. I have 8 here, but there's no 8 here, so that's one thing. Now again, you can also work with two lists at a time. So let me create another list here, say having the elements 9 and 10. And what if I want to combine these elements together of this list and this list? So one way of doing is just extend. So if I do L1 dot extend L2, the elements of L2 will be in here. So what you can do is split this. You can see here at the bottom we have 8, 9 and 9 and 10 as well in the L1 list now. So that's way of combining L1 and L2 lists, you can say. Now another good method that you should need to know is the count method. So if you want to get the count of a value in your list, so for how many times a particular value occurs, so you can do that. Say I will do maybe 1. So I'll just print this now. And let's see 1, because 1 occurs one time. So if I change the list now and I keep 2 values for 1, and now if I do it, you can see 2 here at the bottom. So it gives you the count of the elements, this particular value in your list. So I think that's enough for list. You can just go online and look for all the methods. There are various methods for list, and it's not possible to cover all of them here. So but consider that list is really important. You will be working with list a lot. Let's go to the set. Now the only difference between set and a list is that set doesn't allow for duplication. So if you have say set 1, and there are again two ways to define a set. First is the keyword set that you can use. So this S1 is now a set, or you can another way is you can just use curly braces, and now again just define elements. See, this is also a valid way of describing a set. Okay, now if I give another value, say, and I will print this. So for now I will just comment these lines out. So let me just run this. Maybe I'll clear it first. So you can see we have our set here. So now again you can add a value here. Let me show you for the duplication thing. If I do that, see, we have only one. Though I have initially kept one twice here at first and the last element, while in the output we have just once. So we have the number one just once. So that's one thing that you need to know. Duplication is not allowed in sets. Okay, and another way is you can also add elements to set. So for example, add what we will add 7, and now I will print the set. You can see we have 7 here in this set. That's the way. Again, you have a concept of frozen sets. So when you define it as a frozen set, it doesn't allow adding elements. So again, I'm not going into details because we don't require that much. You will use that definitely for mainly because of this duplication thing. When you want to remove the duplicate elements, so that time you will definitely use set one of the and these set has all these operations of union, intersection that we have in our set theory. So if you are fond of if you are really fond of mathematics, you can just check it out. There are various methods that can help you to achieve it. Operations of set theory in Python with these sets. Okay, enough of sets. Okay. Done. Now we will move on to dictionary. Dictionary is one of the most important concepts in Python, and again we will see how we define a dictionary. The keyword is dict. Dict is the keyword that we use to define a dictionary, and the other way is curly braces. But the catch here is that it's not same as the set defining a set, because in dictionary we have key value pairs. So for example, and this can be not necessarily be strings, it can be integer value or any other value as well. So key one, and I will print value one, and you can separate them with commas. So this is a key value pair, this is a key one, and this is value one, and these together form a key value pair. And similarly, I can have another pair. This was value 2. So now if I print d1, then we have dictionary here printed, and you can traverse this dictionary, but for that you need for loop. So we'll get back here when once we get through the for loop. But now just have a look at the conditional statement. So conditional statements are just used to check for particular conditions. So for example, if we say a is equal to 10, so we can check if, so if is a keyword again that checks for a particular condition. So we will say if a is greater than 0, print greater than 0. So this print will print it as if and only if 10 is greater than 0, right? Again, we can check multiple conditions using another keyword elif. Elif a is greater than 10, print greater than 10. Else, So the keyword else defines the default condition. So if none of the conditions above else are met, the else statement is executed. So I'll just write else statement. Oh, if I just run this, what would happen? Notice that uh, 10 is definitely greater than 0, but it's not greater than 10 itself. So only this condition will be executed and we will be having greater than 0 printed here. Let me run this. Greater than 0. So another thing is that instead of elif, you can use if as well. So if I do this, so what is the difference between if followed by another if and if followed by elif is that if uh, for for this condition here, even if this condition is met, the Python will still check for this condition. So this can be a little slower when you are working with huge data or something like that. But when elif is here, it stands for else if. So if this condition is not met, then and only then it will go for this condition. So that's one difference that I wanted to highlight. And yeah, I think, and this else is just for the default. If so, if this condition is not met and this condition is not met either, then this condition this part of code will be executed. That's one thing. uh, okay, I think this is enough for conditional statements. Let me now go through for loop. And to understand for loop, one of the things you need to know is this concept of range. So print range here, range of 10. Let me run this. Range, okay, we'll just from 0 up to 10, and this 10 is excluded, just as we saw previously in the slicing part of list. So 10 is, so it will print from 0 to 9. So the total elements will be 10, but it will be printing from 0 up to 9. Now using for loop, you can traverse into these elements. So for I in range of 10, print I. If I just do this, as this will be printing everything from 0 to 9. Let me clear first. So let's run this. You can see everything from 0 to 9 here printed. Now you can also use for loop to traverse through uh, list, for example, a dictionary as well. I told you previously. For now for this, let me just uncomment this so we can use previously described things. So see, we have this list L1 here. So let's traverse through it. So what we shall do is for I in, and instead of range here, now we will just write L1. So now print I. So what this will do is that I will initially take the value of the first element in the list L1. It will print it. Then it will go to the second element. Then I will take the value of the second element of the list L1, and then it will print that. So that's how it goes, and that's how it printed these all numbers as well. So let me print again. So you can see all here these numbers. These are just because of those operations that we did, all these elements. Okay, and you can also use for loop to traverse through the key value pairs in the dictionary. Let me go ahead and comment this. and I will uncomment this. Only this much. Okay, previously I think I printed L1.com. That made issue. Okay, only D1 now. So for key, so now we will take two variables in D1 dot items. So note that in dictionary we have key value pairs. So uh, we will be using two variables to traverse. So key variable will be traversing through all the keys, and value variable will be traversing through all the values. Let me just format here. So I'll keep a placeholder here by using these brackets and dot format of key. So key will be printed on this place. I can do the same thing to get the values. Value and let me clear this so you can see. You can see key key 1, value 1, key 2, and value 2. So that's how you can use for loop. Again, I will leave it in the description some tutorials on YouTube itself that can help you to go into the depth of Python. But I think these are the most basic things that you need to know. In the next video, we will be talking about the concepts that we will require in the future coming videos of our project. So this was just a basic overview of Python, and I hope to see you in the next one. Hello. So in the previous video, we discussed some basics of Python. Uh, in this video, we will be talking about some more advanced concepts than the previous one. Uh, if you are very well versed with Python, you can still skip this video if you know about all these things that I have listed on your screen about error handling, global variables, lambda, and functions, because this is what we are going to discuss in this video. So let us first start with function. What is a function? Function is generally used to some task that you will be doing repetitively. So instead of writing that some sample code again and again, it's better you can just write it once and then reuse it again and again. So to describe a function, write a function, we use the keyword def and followed by the name. So sum, say for example. So we have defined here a function, the sum, and we will write what it will do. So first we will write the arguments. So maybe it takes two arguments. So arguments is something sort of input to the function that it will process or do something with it. So we can just do print a maybe. Now we have defined function. That's done. It will just print one number. Maybe we can also print b. And now what we are supposed to do is we can just simply call the function. Again, I think I should give it some numbers. It will be a better name because we already have an inbuilt function. Some numbers, and I will give two numbers. You just print initially. So this is the way you call a function, a function that you have defined, and this is called user defined function. So let's print this. You can see 5 5, both are 5. It is just simply printing these elements. So another thing that you can do is return something. So if you process something, then you want to return that result, you can return that. So there we have the keyword return, and it will return a plus b, and hence the name some number. So when it returns something, you need a variable to store it. So since it returns only one value here, it's just returning this operation here. So it will result into one variable. So I will just take say for example c is equal to some number, and I will print c. So this will print the addition, and since I am giving 5 plus 5 and 5, so it should be 5 plus 5 10. Let me do this again. You can see it here, it's 10. That's one way. For suppose if we are returning two values here, so a and a minus b. Now if I run this, that will be some issues. 10 and 0 directly it's taking, but I don't want that to happen. Okay, I want in the variables, so I will take another variable d, and I will print d. So 5 minus 5 should be 0. You can see it returned this tuple here. Here just a tuple. I have not discussed about tuple, but it's a tuple. Okay, and let's print d. You can see it's 0 here. And let me just show you that it's actually c is also 10. And you can see 10 and 0. So that's one thing. And now again you can assign some default values. So say if I don't pass any value for b, you can just keep it 0. So these are the actual arguments, and these are the formal ones. So and you are here these phi, I am just giving this phi as the value for a, and phi is the value for b. But for suppose if I don't give that, I just return phi, then the by default 0 value for b will be 0. So that's what I'm doing here. So it's one of the another way. Now there are various other concepts like defining by name. So I can also give it like this: a is equal to phi. This is by name, giving the value by name. There are like variable length arguments also possible. We also have that concept, but again it will be a little advanced and not much required. So let me comment this now. So I'll just comment it out, and we will move to the next concept, lambda. So lambda is nothing but a function itself. We call it an anonymous function, but it can do things pretty quickly. In fact, I mean by quick I mean it can just do that in a single line. So you do not need to define explicitly above a function like this and then use it this way. It's a one-line function that you can define instantly. Say for example, you want to square a number. Say so, I can just like square number. It will hold the value, and we have the keyword lambda that initializes this lambda function, you can say. And now I can give my variable here. So lambda and say number, whatever it is. Now I can to square. I can just give number into number, and now this is square number is now a function, right? So if I just directly do print of square num into 2, then 2 square is 4, so we should get 4 here. Before that I will clear this. uh, Let me print. You can see here 4. So that's a sort of writing short neat code rather than defining all things like this. That's one way you can do it. So that's one concept that I want to talk about. So now I will move on to the global variables. So we have talked about various types of variables previously, like boolean, string, float, etc. But again, there are other types of variables like global variables and local variables. When you define a function, and if you define a variable in that particular function, then that particular value exists just for that function. And you can have these global variables with the same name as a local variable. So for example, say we have a variable with a value 10, and I define function as something, so it takes nothing, no arguments, and I define another variable and give the value as 5. Now notice that we have the same name for two variables here, a is equal to 10 and a is equal to 5, and I will print it here, local variable, and dot format. Man, it just run it. I was not intending to run. Yeah, clear. Ah, okay, and now I will just print outside this function, and I will call it global. And so the thing is, I'll just need to call this function for sure, so it can be executed. So the value of a inside this function is 5, but outside will be 10. So no matter what. So although it looks that I just overwritten the value and it will be 5, but it will be 10 here, and you will see that shortly. Let me run this. So you can see here the global variable is 10 and the local is 5. So maybe if you want to change the global variable inside the function, then what to do? So we have a keyword which is global, and you can just define global and the variable name, the global variable name. And now if I do this change a is equal to 5, it will be for this one also. So now I will get both the times 5. So the local will be in this print statement I will get it 5, and in this statement also I will get it 5. Run this. You can see here both the values are changed now. So this is one of the concept that we will be using as we move ahead in the project. It is an important concept that you can remember. Yeah, comment it. So we are done with the global variable concept. Now error handling. So while we are writing code, there is always a possibility that we will encounter some errors, and we should know how to handle them. Uh, for example, let's write another function, say divide, and again this takes two arguments, a and b. and we will just do print a divided by b. So if I run this, say divide and 5 by 10. I run this now. Let me clear this first. So if I run this, you can see 0.5. That's right. But what if I do 5 divided by 0? Division by 0 is not possible. We know that. So if I do that, you can see we have 0 division error. So it's just saying that you cannot divide by 0. So while writing some application that we'll be writing, if we have this error, then it's not good. We need to do something. If we encounter this error, then there should be some way of handling it. And that's where we get this concept of error handling. So we use this keyword try, and so it means try this, but we use except. So you can see a zero division error. Print, sorry buddy, can't divide by 0. So what happens here? So when we pass the arguments, it will first try this. If the non-numbers non-zero number in the denominator, it will just print the division. But if there is an error, uh, uh, so of this particular zero division error, then it will just print this statement. So let's see this in action. We can see here, sorry buddy, cannot divide by 0, because I had passed the value for denominator as 0. So it was so it encountered this error, zero division error, and then executed this thing. So this is also a concept that we'll be using in our project to encounter one of the errors. So that's it. I think I don't think anything remains. I think we are just ready for with respect to Python. But I want to introduce Qiskit to you in the next video. So we will be getting through to some of the basic things in Qiskit in the next video, and after that we will move back to our project. And I think by then you will be ready to understand all the stuff ahead. Thank you. Hello. So in this video we will be going quantum. So we'll be discussing a few things about very basic things about Qiskit, about how to initialize the quantum circuit, how to add gates, the various types of gates, and how to measure. So before we go into this, and also we will also see how the visualization happens. And one of the uh, functionalities that Qiskit provides us, and we will see how that happens and how we incorporate it with our project. And so okay. So before we proceed, anything quantum, any quantum circuit actually has three parts. That three actions that you need to undertake to work with a quantum circuit. The first state is the state preparation. So to it's not required. This part is not required in basic things that we are about to do. But if you're doing something like quantum machine learning, for example, then you need to encode your data, and this step is called state preparation. But for our case, we are just happy with the initial state that we get, which is zero ket. So we are okay with it. So the next step is applying gates. So in the second part, you apply all the gates that you want to, and according to your requirement and the operation that you are trying to do. So in the third part, you take the output using the measurement operation, and for this you require classical bits, and usually these are the same as the number of quantum bits. So for one classical bit, so for one qubit, you have one classical bit. So let's see how it goes in Qiskit. First of all, from Qiskit, import quantum circuit. Again, you can use quantum registers to initialize uh, qubits and classical registers for classical bits, but I'm just doing it the easy way, I guess. You can explore it in the documentation of Qiskit. So say circuit is equal to the variable circuit, quantum circuit. This is the quantum circuit class, and we will give two arguments here. So I just want say one qubit and one classical bit. That's it. So now we have our circuit ready. Now this just this circuit variable now denotes our quantum circuit. So now we can add gates to this because we don't need state preparation step here because we are doing something really basic stuff. So we can add circuit dot say x and 0. So 0 denotes the position. So since we have only one qubit, we give this value 0. It's just like the slicing in Python that we saw previously. So if we had two qubits and we wanted to do some operation on the second one, we would be giving the value 1 over here. So that's how it works. So let me just print this now. Print circuit. And now I can print. It will take some time, I guess, after that. So you can see here we have a qubit q0. We have this one classical bit that is denoted by this number 1, and we have applied this gate, the x gate, not gate, you can say. Now let me show you another thing. Circuit dot barrier. So barrier is just used to differentiate your various parts of the operation that you are doing. So you will be applying various gates to your quantum circuit, and all of them will be having specific purposes. So to accomplish one particular task, uh, you will apply a few gates, and you can use this barrier to differentiate this task from the next task that you will be doing on this quantum circuit. So it's just that. So if I run it again, you can see this line here, and this is the barrier. This is sort of a differentiator between your parts of a quantum circuit. Now, the most important part, circuit dot measure. And we can give 0, 0, which means that the 0th qubit will be measured and its value will be stored in the 0th classical bit, which again the 0th classical bit just means our classical bit that we initialized here. So it's simple. Okay, let's see. You can see this measurement operation here. So we have applied the X gate, and we kept this barrier, and with this measure we just measured this qubit here, and its value will be stored in this classical bit. Okay. Now another good thing that let me just clear this for visualization purposes. So from Qiskit dot visualization import visualize transition. So visualize transition will help us to visualize the transition. The pop-up window that you used to see when we click the button visualize, and this is that was nothing but this visualize transition. So it's that simple. So if I do this and I run it now, let's see what happens. You can see here window has popped up. It's hanging a little. My system is hanging a little. You can see, and it will end up here in one. We know that. So this pop-up window that came up and this visualization of transition is this function visualize transition. And another key thing to note is that we we can't keep measurement in the circuit, so we can visualize only before measurement. Because for measurement, after measurement, the state collapses and we have either one of the basic states. So that's why when you use this visualize transition, you need to use it before the measurement. Okay, so I think that's it for this video. It's a short video, I know, and I just tried to cover the most basic things that we would require while working on the project ahead. And I hope you like this. And in the next video, we will dive into the project again and we will code the functions for about button. I hope you too see you there. Welcome to the video, all the quantum enthusiasts. So this is what we have done so far, and if you have made this far, congratulations to all of you. And in the next few videos, we will be working on the most complex things of the project. But before moving towards it, I just want to recap all of the things that we have done so far in these 12 videos, in the previous 12 videos. So in the very first video, I just gave you introduction to the project, uh, about this tool that can help you to learn quantum computing in a better way, a more visual way. So whenever you are writing down any of the math and you are working on that mathematics, then you actually can visualize and understand better. Then in the second video, I talked about the installations that you need to do. We talked about virtual environment. Why is it important? Also, I gave you a few resources that can help you with this virtual environment installation and working with it. In the third video, it was just an extra video that was to help the beginners that who don't have a good computer science background and may find a little difficulty in doing and working with all these things. So there I talked again about installations, how to install Qiskit. I showed you by working with the Anaconda, and I also told you how to install Tkinter. In the next video, which was the fourth video, we talked about we started our project in fact, and we worked with logo and window. So first of all, I showed you a website that can help you to select your logo. I also told you why I selected these glasses as the logo for my project. Then we saw how you can give logo to the window, uh, to your main window, how to create this window in the first place, and that was that for this for that video. We just did that the two things. We gave it the logo and we made the video. The only other thing we did in the video was giving. I just showed you the color picker website that can help you to choose colors that you can use in your project. Then we came to the video number 5. In the fifth video, we talked about frames because we were about to work with layout, and before working with layout, it's important to plan your layout, and we did that using frames. So we had two frames, the display frame, and that consists of this screen that you can see here, and the other frame was the button frame that consists of all these buttons. The frames helped us to plan our layout and distinguish it, the distinguish it different elements of the app from each other. In the next video, video number 6, we talked about the user buttons. So all these are the user buttons: clear, about, visualize, and quit. And we saw what are they all about. And it was just that video. We all just uh, I just told you the functions of all these buttons. In the next, that is the 7th video, we started with the actual quantum stuff. I showed you the basic single qubit gates of X, Y, Z, and H, and we also saw the mathematics behind all these gates, the matrices in particular that represent these gates, and uh, we also saw some of the calculations, and we visualized uh, some calculations, and I demonstrated how this tool can help you understand better all those complex mathematics. And in the next video, video number 8, we again gone through all the remaining single qubit gates, all these S and SD. I told you what all these means, and what are the corresponding matrices, what is their meaning, and we again visualized a few concepts using our tool, and again demonstrating how it can be used. In the video number 9, we directly moved on to the layout. We worked completely on our layout. We inserted all of our buttons into the layout. I showed you all the different elements that can help you to do it, like sticky, column span, row span, and how you can use all these elements to make your app look good. So that was a great important video, and basically in that 9th video of layout, we completed our layout, and I also told you to come up with your own layout. So that was all about the video number 9. So after that, we talked more about some basics. So in the video number 10, we talked about some basic Python that had particularly nothing to do with our project, but it was good to know about these things because if you want to work more into the in these uh, quantum computing, it's better to know Python. It's one of the most dominant language out there. So I just gave you a brief overview of all the important things that you may need while working with Python, and also I provided you with some few free resources that can help you to go deeper into the Python and learn more core concepts. After that, in the video number 11, I again kept talking about the Python basics. So we talked about concepts that would be useful ahead in our project that will be now working, and all those concepts were anonymous functions, lambda, how do you define a function in first place, what is a global variable, and all. So it was a more complex thing than the previous video, video number 10. But video number 11, I just showed you what are all the concepts that would become helpful once we start working ahead. In video number 12, that is the last previous video, we talked about the basic Qiskit. How do you initialize a quantum circuit? How do you apply gates to a quantum circuit? Then what are barriers? How they are used? And how do you perform the operation of a measurement? So uh, how do you do a measurement? What is measurement, right? So how do you store the result of a qubit into the classical bit? You just use dot measure and pass on the qubit number and the classical bit number. I also told you that there are various ways to initialize quantum circuit, and I showed you resources that can help you further deepen your knowledge about Qiskit in particular. And now in this video, that is video number 13, I just wanted to do this recap because it's important. We have almost completed more than 60 or 70% of our project. A few things are yet remaining, though few. They are really important to do. So now, as we move ahead, the road ahead consists of giving the command attribute to all these buttons. So we have already initialized our buttons and packed them into the window using the grid method. So, but as you can see, these buttons do nothing. Right? I can press them, these buttons, but they don't perform any function. So we will be defining functions now for all of these buttons that they will perform. So whenever I click on visualize, so that window should pop up. So how all that happens, that will be the road ahead, and we will also see how all the concepts that we saw in the video number 11 will come into picture. And I hope you are excited to move in this journey ahead. Thank you. Hello, quantum enthusiasts. And so far, we have done this thing, but what we are about to do in this video is this. So in this video, we will be working only on this about button, nothing else, and we will see how this pops up as soon as you click on the about button. So I've already coded. So while I show you the code, I can actually while walk you through the code, so I can just show you what the code means here and what function does what. So let me just scroll up. So in one of the videos in the Python basics part 2, we talked about defining a function. So whenever you want a button to do something, you just first need to create a function and then provide it to the button. So that's the first part here we do. Uh, Here we define this function and we call this function about. We give that name. The function takes no arguments, and then you can see we defined info is equal to tkinter.tk. So info, you can think of it is this window that you can see on your screen. So that is that window, very similar to what we had done for the main window, which was named as root. We now give title to this as above, that you can see over here, right? And then we define the geometry. Again, I've gone through some trial and errors, so you can do that too. We restrict the size, so you can see I cannot resize it, right? So I have done that using this info.resizable command. Then we come up to here, text is equal to tkinter.text. So this is just a way of inserting the text, and we will see how this comes into the picture of displaying all this text that you can see. Now, before that, we create a label. So it serves as a sort of heading in here, and you can see tkinter.label, and we define the root here. Root here means the window, so window is this info, and then we define what is this text that we want to display. So it's about quantum glasses, and then we provide the font, that is this font style and this font size. So if I show you, see, this is the one, this that you can see about quantum glasses, and there it's Arial, and the font size is 14. So this serves as a sort of heading, and I thought it looks good, so that's the only reason I kept it here. So then we move on to the text to display. This is just a doc string. Just think of it as a string, and I literally written everything that you can see over here, all these things up till here, and whatever you write in this thing will be displayed. So I just created this doc string, wrote everything here. So that's just text to display. Now I pack this label. So the label was this thing, this heading about quantum glasses. Then it was text.pack fill equal to both and expand equal to true. I already told you in one of the previous videos that what do these commands mean. Then it was just packing this command, so and fill everything, right? Then we use text.insert method, and we display this. So end is again a keyword that we imported, and if I show you, yeah, from tkinter import end. So it's a keyword that we need to use, and the second argument is the text, right? Now let me show you what would happen if I just inverted the position. Change this, and let me close this for now so I can save and run it again. Right, let me run this. And see, nothing is here. That's the importance of running those arguments. Uh, so, right, okay, just a second, let me close this again so I can change it. Let me show you what these arguments mean. Okay, so that's it. So, from the beginning here till the end, that's what it meant. And the text can be anything, it's just a string. You can write whatever you want. I just gave some basic info about the visualization tool, which is for single qubit rotation. I am the creator, what I use to create it. Then I just gave these simple definitions to each of the gates, so the user can understand what do they actually mean, and these are the Qiskit commands correspond to that particular gate. Then I just talked about a little more specifically about RX, RY, and RJ gates. We will talk about them once we get there, and we also see about handling this visualization error. We will see that soon. We also talked about error handling in one of the previous videos, and this is something that I will tell you at the end. What does that mean? And again, we have to code it for that. So this line is important. So as the last step, we just do info.main loop. So what happens is that it's continually running. So even we had root.main loop. If you see here, this is root.main loop. So it keeps our main window running when the file is active, and when the about button is clicked, this thing makes our info window running. So and as the last step, don't forget to give command equal to about. So this is command is an argument, and you pass about the name of your function, and now you have linked your function with your button. So that's the last step that you need to do, and that's everything for the about button. In the next coming videos, we will have a look at the quit button and the visualize button. So I hope you are excited for the next video, and that's it from this video. Thank you. Hello quantum enthusiast, and welcome to another video of this playlist. In this segment, we will be working with the quit button, this one. So whenever I press this quit button, the window should close. That's the only function of this quit button. And another thing that we will do will be just initialize the quantum circuit. So in the upcoming videos, we will be working on all these single qubit gates. We will link them with their respective functions. So whenever I click any of these buttons, the corresponding letters will be displayed here, and it will also apply corresponding modification to the state vector. So we will see that in the upcoming videos, but for this video, it's only about the quit button and initializing our quantum circuit, right? So let me just comment this one. We don't require it for now. The thing we require is this. So we import the quantum circuit class that I showed you in the basic Qiskit part, mostly part number 12, I guess. Uh, and I showed you how to initialize a circuit and how to work with it. So we will work with it by initializing the circuit, and here's how we do it. So you can see this this is the function initialize circuit, right? Again, the function doesn't take any arguments, and now notice that we have keyword global here. So the scope of this variable circuit is this complete file. It's not a local variable for this function. So now circuit is available for the entire file, right? Uh, I hope you recall this keyword global that we talked in the Python basics part 2 video, video number 11, if I'm not wrong. So we define this keyword first, and the name of our variable. Then we just use quantum circuit class, to make this circuit represent our quantum circuit that we will be working with, and in the argument I just pass one qubit. So note that in the visualizer tool that we are making, we cannot visualize measurement, right? So because whenever you measure, uh, the state vector collapses into one of the basis states directly. So for our case, maybe 0 ket and 1 ket. So you get either 0 or 1 when you measure, and there's no point visualizing that. And you so if you uh, measure, you cannot visualize it, right? So therefore, we don't pass the value for any classical bit. So in here, uh, our quantum circuit has only one qubit, no classical bits, because we actually don't need them. Okay, so that's it for our function or initialize circuit. It just initializes the circuit. Let me write initializes the quantum circuit. I know it's not a great way to write it this way. Actually, you should write the function returns, what are the arguments it takes, and if it takes any, and if it does take any argument, what are the expected data type, maybe integer, float, string. So that's how you define it. Another thing that I want to tell you is that usually we don't use global variables. We try to avoid global variables because they can result into possible errors that then can be difficult to solve. So in here, our code is really short. It's just about 200 or 250 lines approximately. But when you're writing longer codes, they can create problems. So it's not really recommended to use global variables. Another thing is you write global variables in caps. So in the capital letters, it should be like this, but I have not written it. Maybe because initially while I was developing this program, I just thought of uh, developing it for myself and using it to visualize stuff. It's just for personal thing, personal tool that would help me with quantum computing, quantum machine learning, and so on. So, but if you are writing the code or any time you are any code, not only this project, remember that you write global variable in caps, so they differentiate, so you can easily distinguish between a normal variable and a global variable, right? So that's the only convention. Uh, so that's all about this initialization purposes. And we defined here theta is equal to 0. And this theta will come into the picture when we talk about the Rx, Ry, Rz gates at that time. As of now, you don't need to worry about this as of much, but we will get back to it when required. So that's all about the initialized circuit. So now we have, in this line, we just call our function. So now when it's passed, this file runs, we have initialized our circuit and our quantum circuit is ready with one qubit. So that's it. Now let me move on to the quit button. You can see here, it's really simple. Uh, command that the function that it needs is we already have it, so we don't need to specify explicitly a command. So what I will do is command is equal to root dot destroy, and that's it, all fine and good. So what does root destroy means? It destroys the window, and that's what we actually want. So we don't need to define any function explicitly. We can just give command is equal to root.destroy, and that's it for the quit window. So let me save everything and run. So here we go. Nothing will be nothing will be able to tell us if our circuit has initialized, because nothing has no functions have been given to these all buttons. So we can not verify if everything worked right with the initialize circuit method, but never mind, we will be working in the upcoming videos with all these buttons. So let me click on quit, and when I click, the window should close automatically. So let's go, and that's it. So it destroyed the window, the application closed, and that's what we wanted. So in this video, we talked about initializing our circuit, the use of the global keyword, and some things related to the same. And we saw uh, this help from this command root.destroy that saved us from defining a function explicitly for our quit button. And so that's it from this video. I hope to see you in the next one. Thank you. Hello, people. So, in the last video, we saw how to use and code the quit button. In this video, now we will start working with the single qubit buttons. So, all these buttons you can see here, X, Y, Z, R, X, S, T, D, H, all of these single qubit, I say quantum buttons that uses quantum computing. So note that all of these buttons actually have two tasks to perform. So the first task is whenever I press any of these buttons, it should be displayed here. So I can see the sequence of the operations I've done on my qubit. Just like a normal calculator that we use, we uh, perform various calculations, but and to track them, we have the screen that helps us to see what are the calculations we are performing. Similarly, we have this feature here, and another function that all of these uh, buttons should perform is applying their corresponding effect on the qubit. So if I press the X gate or the NOT gate, then it should correspondingly have an effect of the bit flip, okay, on our qubit. So these are the two things that we need to code, and as we know, uh, to make a button do certain tasks, we need to code a function for it. We need a function for it. If we already have it, well and good. If we don't have it, we have to code one by ourselves. So in this video, we will particularly try to focus on a single thing, that whenever we press these buttons, something the corresponding notation should be visible over here in the screen, right? And the function that you can see here helps us to achieve that. Okay, let's demystify this thing. Close this and uncomment this. Yeah, so you can see here, add a corresponding int notation in the display to track the operations. And the second function is if the number of operations reach 10, all gate buttons are disabled. Now let me explain you this second thing. Okay, so the Qiskit functionality that we use for the purpose of visualization only supports at max 10 operations. So you initialize your qubit, and after that 10 operations can be done, right? It does not support the 11th one. So after you have worked, say applied 10 operations, somehow we need to disable the buttons so that we are uh, working with the reset functionality and it does not cause any errors, right? So at, now displaying a number, any string is really simple. It's just display dot insert. It's that simple. So remember, display here denotes our screen, and this gate input is actually this gate input that we receive from the corresponding buttons. So this is just a string. Think of this as just a simple string, and we take that and we just display it. We actually insert it, and this end helps to denote the position. We already saw this end in I think the about button, and we were working with the about button. So the display part is pretty simple, nothing much of a headache. But when you come here, you see that a longer code is required for the disabling the button. Now let me walk you through this. Uh, I will walk you through this, but it will make more sense when we will complete coding all the gates and then finally return and see this thing in action. Let me, as of now, just think of it as code that you are going through, right? So display.get gives the entire string that is on the screen. So in your display screen, whatever is displayed at that moment, you get all of it using this input gates, right? And now you store it in this variable input gates. Then you get the length. So you basically see how many characters are there in the string that you have got from this display.get. Now this just denotes, as you can see, number of gates pressed, right? And then uh, we convert it into a list, the input gates. Now note that for single qubit gates we use just say one single character. Like for X gate, a simple X can denote it, right? But for the R gates, RX, RY, and RZ, we need two characters, RX and correspondingly RY and RZ. So we use R so that it separates the X gate and RX gate on the screen, right? Now the catch is that we are trying to get the character using the number of characters on the screen. We are trying to determine how many gates are pressed. But in the case of these RX gate and these gates, which are the dagger gates, SD and TD, a single gate is applied, but there are actually two characters on the screen, right? So we need to write a little logic so that we can work with these things. We can apply our function very well, right? So now we define a list with these two characters R and this character D, right? So this is a simple list. Search word is now the simple list with these two characters, you can say. Now, now what you see on here is called a list comprehension. Now, remember in one of the Python basics video, I talked about for loop, and usually you use a for loop to traverse through your list and apply various operations, right? So list comprehension is just a simple and neat way to do it. So in a single line of code, you are able to perform operation and work through a for loop. Uh, Remember, we also had lambda that was a neat way of working with a function. Similarly, here list comprehension is a neat and simple way of working with for loops and corresponding list operations, right? So for I in search word, so remember we had this list search word, and now using this for loop we are traversing through it. So at the very first instant, this I would have the value of R, this character that you can see, right? Now we take our list of input gates. So at this moment, it's just a list that contains all of the characters that are present on your screen at that moment, all those gate characters. And we use this simple dot count method that every list has, every Python list has, and we pass this I. So what it does, that it gives you the count of those capital R characters that have appeared on your screen. So basically, it gives you how many times you have pressed either R gate or that D gate, because this we are traversing through this list. So for the very first time, this I has the value R, and the next time when the for loop runs, we have this I taking up the value of D. So now this count double valued gates is a list that contains the counts of these gates Rx, Ry, Rz, and SD and TD, because these gates, though they are pressed once, they actually have two characters that display it, right? Now we take the sum of count double valued gates. So say if we had two instances of Rx gate. So for example, then it will just be two, and maybe one instance of SD gate, then it will be one. So we take 2 plus 1 equal to 3, right? And we subtract it from the number of gates pressed, the length of the input, and that's what we wanted to do. So now after we do this operation, we subtract the length of this double valued gates. Now now we just have each character representing only single gate pressed, because for those double valued gates where two characters were representing only one gate, we have eliminated that extra character using this simple logic. I hope you are getting it. And now it's a simple if else statement. So a simple condition, if now this thing is equal to 10, then number of gates pressed is equal to 10. This is the, remember, this is just a length. So if it's equal to 10, it means that we have already pressed 10 gates. Now let's go into this condition. So if only if this condition is true, we now get back here, and this is a simple list of all the gates, because remember we need to disable all the gates, right? So what we do, we again use a for loop and we disable it. Now this is showing me an error because I have not imported the keyword disabled. So let me just import it here, disabled. There we go. And you can see the error disappear because, yeah, because we have imported the keyword. So what it does, get.config state is equal to disabled. So what it does is, it the button which was enabled, it disables it. So no longer the user can actually press it. So I hope you got the logic, and this is a simple way of how you develop logic and work with Python. So if you are a beginner, I think this was a great video for you. And that's it for this video. And now what we will do, I will just show you a demonstration of how it works. So I will go to the main file. I want to work a little more on our tutorial.py. So I will just run the main.py and I'll show you how this thing works. So yeah, here we go. This is the main file, the already ready-made code that we had initially. So let me just press any 10 gates. So 1, 2, okay, 3, 4, 5, 6, 7, 8, 9, 10, and you can see as soon as I press the 10th gate, all the buttons are disabled. No more I can just click any one of them. So that was it. Now, and as soon as I clear, see all of them are back. So this is one functionality of clear button that we will also see in one of the future videos. So that was it from this video. In the next video, we will provide these buttons their actual functionality, the quantum functionality of applying, their effect on our qubit. So I hope you learned something from this video as well, and I hope to see you in the next one. Thank you. Hello, quantum enthusiasts, and in the last video, we worked on one of the functional functions that our single qubit gates need to perform. Single qubit buttons, I should say, need to perform. And in this video, we will link those single qubit gate operation buttons, or quantum buttons in short, with their actual functions, the quantum effect they have on our qubit. So let us work with that in this video. So, so I will do uh, the command. So we know that using this command argument, we link our button to the function we want it, the task we want it to carry out. So now remember that we had our button to perform two tasks. So now what we'll do is we will use lambda. Remember this lambda is the keyword of writing of working with functions in a neat and simple way. Now we will use a list, and this list is of functions. So these two functions will be performed one by one. So first one is the display gate that we already worked in the last video, display gate, and now comes a particular operation that our gate will perform. And since we are working with the X gate, as you can see, so the simple function is circuit, the global variable. I want you to recall the global variable circuit that was denoting our quantum circuit, and we will apply the gate X, right? That's what we want to do, and that's it. That should work pretty fine. Now let me do it for all the gates, and I'll just copy it because I am lazy, and I can control alt, and there we go. Now I can do is again, I can just do it Y for the Y gate and Z for this one, right? Now we need to leave RXRY and RZ gates apart for a moment because they need some more additional coding, and we will look at in the next video why they need extra coding other unlike these other gates. So let's leave them for now, and I'll take these things, and we have a few gates left. T gate and T dagger gate. So now what we shall do, we shall do this S gate. So S, you can see it's showing me the functions S dagger for SD gate, and for header mod it's a simple H. Now let me go to the other one, T. You can see it showing me T and T dagger. Now from the last video, I remember we needed a character that will be displayed on the screen of our tool that will remind us and help us to know the sequence of the operations that we have applied. So that's an argument that we need to pass. So again, I will use Control Alt down arrow key that way, and I'll do this. Okay, now X, Y, and Z. Pretty good. So X denotes the X gate, Y denotes the Y gate, Z denotes the Z gate. So whenever we press any of these buttons, corresponding character will be displayed on the screen of our quantum glasses. Okay. Now similarly, let me do it for all these. The name for this we had S, and for the dagger gate SD. You can give anything you want, but I've named it this way. And where we go, yeah, here. Now T and TD, maybe T should be capital as well, and there we go. So I think this is all fine and good. So we have linked our buttons to their corresponding functions, and it will perform both of its required tasks except for these three gates, Rx, Ry, and Rz. That will be, and we will look about them in the next video. So let me just run this thing and see if it works well. And let me begin missing one argument, Qubit. We had an error. Oh yes, I forgot. We need to pass on the qubit number 0. We remember we only have one qubit. One qubit. So 0th qubit, and that should work fine. Let's see now. So X, yeah, that's fine. It's still displayed here. And let me press 10 gates and see if that works. How many I pressed? 1, I think 2, 3, 4, 5, 6, 7, 8, 9, 10. No, I think I missed one. Let me do this again. Oh, I don't have it. Clear functionality. Let me do this again. This time I will count it. Come on. Yes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So I miscalculated. My code was right. My counting was wrong. Okay. Okay, let me close this. So I think that's it for the video. In the next video, we will be working with the R gates, and I think they are the coolest ones. Okay, I'll see you in the next one. Hello, quantum enthusiasts. And in the last video, we completed coding our quantum buttons, except for the three Rx, Ry, and Rz. And so, in this video, we will be working with these buttons, uh, and we will see why they are different from the other ones. So, let's answer the last question first. So why are these buttons different than the ones we worked with in the last video? So the point is, these are parameterized gates, and what does that mean? Mean is that it takes a value theta and it uh, does rotation by that particular value of theta and apply. I mean, it applies rotation to the state vector by that custom value theta. So in other gates the Z gate or Y gate, X gate, S gate, we just had to click the button and it was definite amount of rotation that it used to give. But that's not the case with these gates. They give a rotation in their respective plane, but with the custom value of theta. So that value can be pi, 2 pi, pi by 2, also negative pi by 2, negative 2, so and so on. So for to get that user input, we need to code this little extra functions, so that it will give us ease while working with these gates. So exactly speaking, we will need two functions for this, and let's see how that happens. Let me just uncomment this thing. Now note that we will be using another window to take the user input, right? So as you can see here, we do that standard thing. We define the tkinter.tk instance here. You can just think of it here, this get input as our window that will pop up whenever you click any of the Rx, Ry, or Rz buttons, right? Then we give it a title, get theta, and this is the geometry, the size of your window that you want. This is the sort of trial and error method again. Then we don't want either this window to be resizable. So it has a fixed size and the user cannot change the size with their cursor, right? Now, for each of the, uh, now we restrict the user for the value of theta. So the value will range from -2 to 2, so positive 2, with both of the ends included. And these are discrete values that can be passed. So we have in a total here 8 buttons. So we have pi by 4, pi by 2, pi, 2 pi, negative pi by 4, negative pi by 2, negative pi, and negative 2 pi. So these are the 8 options that I've given user to choose the value of theta. Now, what you can do is here, instead of using this button setup, you can just maybe use a entry like the display we have in our main window, and give maybe ask for a simple direct integer input maybe, and use that because so instead of this 1 by 2, 1 by 4, 1 2, you can just using it with pi, you can just take a single input and multiply that number with pi. So it will be user input into pi times rotation. So again, you can that range, give a custom range if you like, maybe not. But I have come up with this thing. I have given 8 buttons and I have asked the user to give any of it. And as soon as the user clicks a button, the window is closed. This window, get input window, because the user has given his or her input, right? So let me walk you through this. This is the tick enter button, as I told you. Then we need to define the window, right? So this is the window, get input, that we want our button to be in. Then we define the height and width. Again, this can be a trial and error. The background is buttons, the background color, and I kept it same as our main buttons. This is the font, so the font style and font size. Now this text value is the value that will be displayed on the buttons. So what is that value that you want your buttons to display? So this is what we want our button to display, pi by 4. So the user knows that when I click this button, it will give a rotation of pi by 4. Now after defining this, we need to link our button to a function that will help it to achieve that particular rotation, right? And you can see here that function is change theta. So let me go back and show you that function. So here we go, and this is that little function. So as soon as I just uncommented, the errors will vanish, except for one, I guess. ONP. Let me import NumPy. So NumPy stands for numerical Python, and it's a great thing that you need to know. It will be used everywhere, especially if you are into machine learning. You will use it for everything, anything, and everything. For your ensemble computation, there are also other libraries, but we won't discuss about it in this video. So I've imported, and that's the error. Import numpy as npo. Sorry, as np. Now it's gone away. So instead of writing numpy every time, it's a sort of shorthand for it. NP, numerical Python. We love Python. And here we go. Change theta. What does it do? So it takes the number of window, a circuit. Now it was unnecessary of using this circuit because we already had a variable, a global circuit. We had it a global variable. But I just wanted to show you that you can also pass a circuit as an argument, right? This window too. You can directly pass them as arguments to your functions. So it's not like your only standard data types like float, integer, string can be passed as your variable. You can pass your custom classes and variable object like also as a argument to a function. So that was the purpose. And this key is a simple string, nothing very special. So remember in the video where we worked on initializing the circuit, we also defined a variable theta is equal to 0. And now it comes into the picture. So let me just scroll up. It should be somewhere here. And there we go. This friend of ours. Theta is equal to 0. Now this variable theta tracks the value of the theta. Like if we apply a rotation, they need to set it back, right? For another gate maybe, because if I apply Rx gate and after it I apply Ry gate, then it should not happen that now the theta value has changed, because that will completely result in uh, it will result in errors, right? Because you don't get the rotation that you want. You will be getting some error over that rotation, maybe theta plus that theta initial value. So that will be a problem. So we need to think about that as well. Let me get back to our change theta. So we declare here global theta. Now this number is nothing but the value passed by user. So if a user selects say pi by 2, then it's 0.5. This number value is just simple point, 0.5 float. And np.pi is pi 3.142, whatever, until it goes. So it represents pi, np.pi. And now we use a simple conditional statement. So we will pass this string key. So what we do is, if key is x, so if the passed key is x, it means that for we have used our x gate. So correspondingly, we will do this circuit dot rx or theta. So that is the value we just got here, and where we will apply it on the qubit number 0, because that's the only qubit we have in our circuit. And after we applied that, we will set theta back to 0, right? So we don't run into problems later on, because say if I first use rx gate and I give it a value of pi, and then if I use ROI gate, and even if I give a value of pi, it will result in actually a value of 2 pi, because it will add pi plus pi. So that will be problems, and to avoid that, we again set back this value to theta is equal to 0. And similarly, we will work with this thing. So t is equal to y denotes the ry gate. We apply the corresponding function. So we have also have the quantum effect of the gate. And if it's not x or y, it has to be rz, because we only have three gates that use this function. So undoubtedly, if none of the two conditions are met, it has to be rz. So we again apply this rz function. So we have our quantum effect of rz gate on the 0th qubit, and then what we do is we destroy the window. And this window is nothing but our window, the user input window, that helps us to take the value of the integer that will multiply with pi here, right? So that's one thing. So you just notice here, you can also pass window as the argument. Now let's get back here. Now you see here, change theta circuit key. Pass all of it. Now remember, here we are working into the the user input window, right? So here we are giving input to these buttons. These are pi by 4, pi by 2, and all buttons that will now and they will now exchange. They will now use this change theta method. But actually, we need to link this with the Rx, Ry, and Rz gate that actually exist in our main window, right? So we need to move a long way ahead, right? And we need to find our gates. Where are they? Here we go. So now command command is equal to, what was the name of that function? User input. So this is the only function, I guess, that we will use, and from here we will directly access the other thing. And as you can see here, this thing also takes two arguments here, the circuit and the key. So when we use this function, we need to pass these arguments again. I think this is unnecessary, the circuit argument, because it's a global variable, but I have passed it for some reason, maybe just to show you. Okay, that's fine. Doesn't won't cause any errors or some problems. Let me get back here. So command is equal to lambda, our magical word, and then we will use user input we'll pass circuit, which is the global variable. Then we will pass a string, which is a simple X. And the same thing should work for all of these fellows here. The only thing we need to do is just change the string y, and here z. Though if we don't pass it uh, the particular z value, it would still work if we just pass an empty string, because it would just follow for uh, by default case. But that's fine. We will just pass it, and I think that's it. We have coded the three gates, and we should just run this and see how it works. Let me press RX. So, did I tell you about this text? I think no. I will get back to you with that. So you can see 8 buttons here that we coded above, right? So if I press this, the window is destroyed and my -2 value is stored. But there's a problem here. The RX is not here shown. To get back here. I made a mistake. Uh, I did not pass the display gate. So it needs to be a list of functions. Display gate and RX. Right. So the user input is also displayed on the screen. Okay, I'll just copy this now over these two lines. Now what I will do is just RY and RZ, and here it will be Y and Z. Now that should work fine. So the only reason it did not display because we had not linked it with the display gate function. That was a mistake. I'm sorry for that. And now if I work this thing, now it should work fine. If I and yeah, we got the RX here, and this is the just sort of notifying the user that yeah, you need to pass in this range, because actually you don't have any option. These are the only 8 available options that you have, maybe 5. Yeah, I'll close it. So we were talking about this change theta, and then we just got off to change theta and the link was broken. So we already seen what this change theta is, what it does, what it or the argument it takes. Let's get back here. We use the dot grid method, our old friend, to insert our button element into the window, and we give the row and column. We specify these numbers so it knows where to place which button. And we similarly do for all the 8 buttons. At places where we require a little adjustment, we use this sticky. It's just for adjusting, how your button is being displayed. So if it's a little going a little off, you can just use these tools for that. Now we again create this text object. So it takes the get input is the window that we wanted to display the text in. I just hide and wait, nothing to explain. And this is the background color that I have directly given as this the string. Now this is the string. It's something very similar we use for our about button. So that's the thing. We just want to notify the user that these are the possible values. This is the range that you can give your value for theta. And what we do, then we just uh, use this insert our element here, and that's it. So this just insert, we just pack it, and the insert shows it. And using these two commands, we tell our text object how to display it, from which end to which end. And this get input main loop is the most important part. It makes the window keep running, so it's important as well. And that's it. We are into the user input function. So a fairly long video, I know, but it was the most important video, I guess, because here we saw two functions, how they link with each other, how they are then applied to a button. So a lot in this video. Uh, Maybe I will recap it a little in a next video, or maybe we just go to visualize. Let's see what we do. Till then, if you feel a little confused, watch the video again, and I hope to see you in the next one. Hello viewers. So in the last video, we completed coding our quantum buttons, the Rx, Ry, and Rz, and now we can move on to the next button. So in this video, we will be seeing the clear button. We'll link it to the function that it needs to perform, which you can see here, def clear. And we will also recap a little on the Rx, Ry, and Rz, because I know it was a little complicated. So we'll be doing these two things in this video. Okay, so let me just comment this. Okay, so there we go. And so what does this clear button actually do? Very obviously, it clears the display, right? It reinitializes the quantum circuit for fresh calculation. So because when we use clear button, we already had applied a lot of calculations, right? And we just don't want to clear the screen. We also want our button to take the initial state to 0 ket, right? So that we can apply a new fresh state of operations on it. And the third important thing that clear button does, that it checks if the gate buttons are disabled. Because remember, if we applied 10 operations, maybe 10, we pressed 10 buttons, then all the buttons were disabled, right? So I cannot just keep it that way. If we clear, it should again, even that should be again go back to the initial state, right? So I don't need to close the program and run it once again. So for that thing, we also use clear button, so that we can again use the gate buttons, right? Now let me walk you through this. Display dot delete. Display denotes our screen. This one, so it just deletes, and this shows the end, the way of deleting from where to where, right? So this will simply clear the display that you have on your screen, or those are X, Y, Z, whatever you have applied on your screen, right? Then we just reset the circuit. So what do? We call the function initialize circuit, and it will be somewhere here. There we go. So we reinitialize the circuit. So now the circuit is back to the initial state of 0 ket, right? Now we come to the interesting part. Now, if we will just check for the state. If a state, just remember that if any of the button is disabled, it just implies that all the buttons are disabled, right? So if we check for X gate button and for its state, this attribute will return its state, and if it is disabled, it means that all the buttons are disabled and the user has clicked on all the 10 buttons, right? Then what we will do, we will again use this list uh, of all the gates and store it in this list, right? And now what we will do, we will traverse through this list using for loop, and we will return its state back to normal. So we will enable those buttons. It's showing here because I have not imported the keyword. No, yeah. Now it's happy, and here we go. Yeah, the error is gone. So what do? We have all these gates in this list, which is named gates. We one by one go through all these gates, and we will enable them when, if and only if this gate X gate is disabled. And X if X gate is, if X gate is disabled, it simply means all the buttons are disabled at that moment. So if the buttons are disabled, we will enable them, all of them, right? So that's a simple thing. Uh, so that's it. That's a simple, clear button. In the next video, I will just give a small recap of the gates RX, RY, and RZ, and I hope to see you in the next one. Hello, people. So, I welcome you to this video number 20. And in this video, we will just link our visualize button to the task it needs to perform. And the only task it needs to perform is visualization. So, for that, we will directly import a function from Qiskit. So, let me import it from Qiskit dot visualization. I would like to import visualize transition. Yes, that's what I want. Now it's a direct function, right? So I can directly use lambda, our magical keyword, and I should be directly able to link it, right? Let me try that. I'll show you. Uh, First, we need to find our button for that. There we go. So it's command. We have our magical keyword lambda, and it is visualize transition that takes our circuit because it needs to know what it needs to visualize. So I do this and I run the file. Let's see what happens. And there we go. Uh, this our tool has popped up. And if I do this and if I visualize and see, we have these things here. You can see here warnings, and they are just about the version thing. That version. You can see it's working completely fine. We'll get it over one cat. So proper rotation about this axis, completely fine, everything good. uh, but something I want to show you, I think I need to use filter warnings to get rid of these warnings so I can show you the important thing. Import warnings warnings dot filter warnings, and I think it's ignore, and that's it. And now we won't be getting these unnecessary version errors. Again, I'll do the same thing. I'll visualize, and you can see this time I get no warnings here because all the warnings are filtered. Uh, we know it will be here, and no surprises there. Absolutely. Now I can close this. I will clear this. Oh, there's a problem. And we'll be looking why is that a problem in one of in upcoming videos. But before this, let me just clear this, and I'll run this again because I want to show you one error that will occur here. So the error is that if I just don't press any of these buttons, these quantum buttons, and if I directly press the visualize button, you see you have an error, nothing to visualize. And that's very obvious because we haven't applied any operation, and if you have not applied any operation, what will it visualize, right? So to handle this error, we need to explicitly define a function, and that we have done. And let me go through this. Where's the function? Here we go. So here we go. And what does this function do? So visualizes the single qubit rotation corresponding to applied gates and a separate tick into window that you just saw, and handles any possible error. So this what you see here is called error handling in Python. So showing red line, yellow, yeah, warning line pause. And for that I need to do something this import Qiskit, and the warning has gone. Okay, where were we? Here we are. So what we are doing here, what I'm saying to Python is that try this thing first. So try to visualize, but while doing this, if you're trying to do this visualization, and if you encounter this error, that is a visualization error, just destroy the window. So if a user tries to visualize without applying any of the quantum buttons, then it will just close the application. And that sounds good. So now we will link this function visualize circuit to our visualize transition. No, we want visualize circuit. Yeah, there we go. And another command is argument is root. So that's the window that we want to close if the user presses the visualize button without doing any operations, right? And or let me run this. And if I visualize now, the window is closed. So you have successfully learned to handle that error, right? And that's good. So I think that's it. That was all about handling the that. And I think I told you that I'll tell you about that clear button thing, but just notice it that I have not linked the button. So the command will be clear, and I need to give it lambda. Let me see what was the name of that. Def, mm, def clear, and it only takes the circuit. So I only need to pass on the circuit and we will be good to go. I just forgot to link the button to its function. And lambda clear circuit. That's it. And now let me just take you uh, quickly through those RX, Y, and RZ gates. So what happens whenever a user presses the button? We have linked these two functions with the button. So the first thing is it will display the gate, right? And now we will use another function, user input, that passes a corresponding string and our circuit object, our circuit instance, or our quantum circuit, you can say. Now let's jump to the user input and see what it is actually. As the name suggests, the user input takes the input from the user by starting another window. Here we define that window, what it is all about. We then define all of its buttons. We also give a note to the user, so the user can see that the available range is this. And of course it is visible though, because there are only 8 buttons left, but we just want to be a little nicer, and we will just give a note. And all of the buttons here use another function, change theta. So what does this do? Change theta, it applies a corresponding rotation to the user input and it closes that user input window. So the window is destroyed and user input has been taken, and we all are really happy about that. I'll just demonstrate it. Let me demonstrate it. It's running. So it's Rx. You can see get theta window has popped up here, and I need to give a value. I'll give pi, and see the window has gone. So as soon as I give the value, it's gone. So I hope you like this series, this tool, and I hope you learned a lot while working on this thing. Now you have a tool that can help you. In the next video, we will talk about what should be the next steps from here. Thank you. Hello, all the quantum enthusiasts, and I really congratulate you for making this tool. And if you have innovated it, I'm really happy. Let me know in the comments if you have innovated it. Post the images, give link to our GitHub links to us. We will be really happy to have a look at your work. And I hope you learned quantum computing while working on this tool. You also learn Python. You also learn basic programming, how you develop logic. And the most amazing thing of everything is now you have a project, you have an app that is based on quantum computing, and now you have something that you can showcase, right? And the best part is you have just developed it without going into any of the complex details of quantum mechanics and the required mathematics for quantum computing. But this is just a mere beginning, right? We have a long path to follow and learning this quantum computing, and also making it possible to use it commercially. And I really hope this series has generated an interest in you to work towards this amazing field, to contribute to this field. And as we move ahead, I'll be focusing more on Python. So the next thing that you might see on my channel would be Python projects, deep learning projects, machine learning projects, and because I only believe in learning by doing. So you will mostly see the project stuff, and but yes, I will cover a few things, a few tutorials, a few concepts that I think you need to know. I will try to cover research papers on the same channel. So because the quantum computing, the field of quantum computing, or say quantum machine learning in general, uh, are very new fields. So most of the info that you get are from research papers, and the entire motive of this channel is to make that information available to you, so that through YouTube, so more and more people can understand more quantum machine learning, quantum computing, and be able to contribute to this amazing field. So thank you. I hope you stick with the channel, and I hope to see you in some of the coming playlists and projects. A very big thank you from my side. Thank you.